And so I give you the welcome to this workshop on cross-border interoperability. Welcome to the people in the room and to the people who are connected remotely. I'm together with good Sander. I'm the moderator of today. Sander, what should we do? Should we get straight in?
Well, yeah, I just have a few things. I just wanted to get a brief little thing to say about cross-border semantic interoperability. So, this is one of my favorite quotes. You know, it's made by a statistician a long time ago, but I think it captures quite well the issues that we are dealing with on a day-to-day basis. You know, with especially cross-border, everybody represents things, and you know, we try to capture the core of what we're trying to represent, but then we run into issues from time to time when we try to exchange data. And I think one of the main things, I mean, why is that we make a model to express something. I mean, if like here is just two layers of OpenStreetMap, and it's the same map, it's the same territory, but we just have two maps depending on a use. One is for transport, one is for cycling, and that if we model the world, you know, we're dealing in an abstraction. The data is the data is a representation of what is out there. Of course, there is also an impact of what we do with our data into the real world. But specifically for if we talk about cross-border data models, it's something you cannot make things context-free. This when we were at lunch, I was discussing with some people about data spaces, and the argument was about, well, we now see competing data spaces arise within the same domain. Multiple organizations that claim to be the mobility data space. And I think this is, I mean, it's the same kind of issue that we're dealing with. Like, you cannot try to reduce everything to one universal model to conquer them all. And that being said, I think that's, I just wanted to highlight a bit the problem what we're dealing with. Data is there, you know, it's a representation of reality. It's not the thing itself. And with that, I think we can let the actual people that provide solutions instead of problems talk about how they deal with this complexity on a day-to-day basis.
We had this one other
yeah. It's what I tried to explain just now. You know, if we're dealing with models, there is always, the more you standardize and go to one universal thing, you increase cohesion, but you also decrease autonomy, and there is this balancing act going on between the two. Like, people don't want to always agree on something specific, so there is a very human part to semantics.
Yes, so if I can give an example of this, what is happening within SEMIC. So for those who would not be familiar with cross-border interoperability, this is when we try to make digital services for the public sector to go across borders. Everything is fine within this when the services run in the national borders, but when you have to exchange documents or request certifications, it becomes a little bit tricky. So what is happening in SEMIC is that when we come up with the data specification, we have a process which is very much governed. So we have webinars where everybody who is a stakeholder sits at the table, and all together we decide and negotiate what is the semantic of certain terms. And then once these requirements are collected, then there is a group of people who formalize them into models. This is one way you can say, help cross-border interoperability. Another extreme would be to let the entities to work more in autonomy, model their domain, but in the research of which design is best for them, they can also pick from what other member countries have been doing, or what is out there as an open source model. So this would leave a little bit, it is less governed, it would leave a little bit more autonomy, and the interoperability would emerge as a side effect of referring to the, say, most popular model, the model that have higher quality. Now, how did we organize this workshop? We organized this workshop presenting to you both these options. We will start with a very highly governed process, and then we move into a section where we'll give you an hint of what is possible in terms of existing technologies, existing approaches, or technology that are new to the stage, like AI, and how that can help into designing interoperable models. We have line item speakers for you, and these are the order in which they will present. So we'll have a presentation from with the title European Collaboration on Semantic Interoperability, with an example of MareGraph project, followed by cross-border domain data spaces, opportunity ahead given by Ed Curry, a peek on what Data Spaces Support Center is doing in terms of interoperability in the data spaces, followed by the experience of Italy with their schema.gov.it, and what does it take for interoperability to be adopted. And then we have a case of reusing ontologies with the current practices and challenges by Maria Poveda. Last but not least, I wanted to invite Stefan Hoppe, who is from another sector. This is from the industry, but Stefan, who is in the other room now, he managed over 30 years to reach industrial interoperability with an enormous amount of partners. So from him, I would like to have a story of how he achieved this, starting from the very bottom, very scratch, and over 30 years, making all of these partners agree on the industrial sector. And so this is now the time that we move to our first presenter. It's 3 presenters, Raf, Georgia, and Evelyn. Yes. All right. The stage is yours. Go ahead.
Thank you. So, good afternoon. 1 year ago, we were also present at the workshop about cross-border interoperability. And there we had a dream on how we could better share our ideas, how we better could reuse semantics. And this dream of collaborating cross-border sparked a beautiful European project where we could test our ideas and gather feedback. In this first session, we would like to share the initial dream again. Then we will present the results of MareGraph. And then we also have, I think, Q&A and also the online questions. So, what was the idea of the dream? Well, imagine that there could be a place on EU level where we could discover all standards developed by cities, regions, and member states, where we could explore them and immediately see which standards has been reused, because it tells something about the quality, but also which initiatives are reusing this particular standard. So this could help to inspire us all. Second, once we're inspired, the question is, how can we lower the barriers for adopting these standards? There we had the idea that once you have selected one of the standards developed in Europe, that you could easily extract it into a workbench where you can easily contextualize it to your own needs, because different legislation might apply, or the standard had to be connected to other existing standards. So this would be a way which lowers the barriers of reusing this existing standard. And then once you have created this extension of the standard, that you easily could share it with the other colleagues in Europe. Maybe a bit like we have metadata portals for open data, that we have a portal for semantics, and that you could just add it to the portal or publish it on your own website, and it can be harvested on a European level, where the standard will be also available in the EU Semantic Registry and ready for reuse. Also, our hypothesis 1 year ago was, when you want to collaborate across member states and regions, then you need a shared process, so a governance on how we are going to collaborate and create this level playing field, as well as a method, a collaboration environment, something like a workbench. So this could lead us to a construction of first, on the left, contribute, so a way to share our standards and extensions, inspire all member states on the EU Semantic Registry, and a workbench for easily adopting it. Now I would like to give the floor to Evelyn and Georgia to share the insights that we have gathered in the Marigraph project. And Evelyn will start with an introduction of Oslo. I think the first time we presented it here was in 2013 at the SEMIC conference in Dublin, and you were there, Georgia?
Yeah.
Please,
Yes.
the floor is yours, Evelyn.
Yes, thank you, Raf, for sharing this great vision that we have indeed, and that we have pursuing for indeed a long time. I was not there at that time, but I will give an introduction into Oslo and into the practices that we leverage into the project of Marigraph, which we are both collaborating in. And so for people, maybe a short poll for the audience. So the Oslo program is the Interoperability program of Flanders. Is anyone familiar with the Oslo? Okay, I see many people raising their hands. Okay, more or less. So Oslo stands for Open Standards for Linking Organizations. And we have thus been creating data standards or semantic assets since 2012. And what is so nice about the program is that we started bottom up from use cases. So what we did this morning, we presented one of the use cases. We start really from cases that local municipalities, other regions are struggling with. And we start from that point towards creating semantic assets. We do this also in co-creation within public-private sector, which makes the adoption afterwards of our semantic assets more enhancing, and we say no to the 50 shades of no, why private sector should not be able to adopt, but we say, okay, if we get you into the process of developing the standards, creating the semantic assets, we feel that it's easier that they also adopt the standards that we have. So at this point, we have a lot of existing standards that we have created. I think at this time, Rav, it was more than 130, 40 recognized standards we have in Flanders. And when I say recognized in Flanders, what our approach is, we actually make use of international standards and also, of course, the European core vocabularies, and we extend them towards our level here in Flanders. So I heard also this morning a nice example of, for example, DCAT. You have the DCAT on the European level, but you also have application profiles and also even a Czech version I learned today about this DCAT profile, which we didn't know about. But in Flanders, we have our own extension on this DCAT version, which is very interesting and I would love to know more about. So we do this in co-creation sessions, and then we come towards these semantic assets that we publish on our website, data.flanders.be, in both human and machine readable language. So what it's also about, as I said, we publish semantic assets, also technical assets. And we provide tools to do that. So we have a whole tool chain towards publishing these assets, which is fully automated. And we offer also support with the governance to come towards a recognized standard. And as I said, we start from use cases bottom up to work towards these recognized standards. And how do we do this? So what Raf earlier told, we have a process and method. So this is the process towards developing these standards. So we have a governance around this. So to come towards a recognized semantic asset, we have a whole procedure of working together, collaborating from these use cases towards a ratification by one of our steering committees in Flanders. And this process and method is, of course, based on best practices that have been recognized internationally. So if you want to learn more about this process and method, this is actually the base for the Marigraph project, because we took this process and method and tested it if it could also work in other member states and could also work outside of Flanders. And Georgia will share her insights on that part. So I maybe now give the mic again to Raf, who will...
Thank you. So it's 4 very basic steps. The first one, what we did in Flanders, but we also did it on an interfederal level with the other regions and now cross-border, is a look which could be our formalized governance, our framework, where we ratify our standards. Second, agree on a transparent process to raise interoperability. And this process is based on ISA Square, W3C, Inspire, etc. That's really important, first for the level playing field, and second, because then you can maintain the standards when they change over time in a controlled manner. Third, an end-to-end method based on linked data that we use for publishing our standards both in a human and machine readable form. And having these basic building blocks, we can start with the co-creation of the standards. So where are we now? Started in 2012. Back then, the standards weren't really ratified in formal framework. We had 2 in 2017, and it increased by the end of last year with standards in 135 domain ratified and 73 in development. At this moment, 41 trajectories are running, and it's in use. For instance, all local governments in Flanders are publishing their local legislation, their local council decisions as linked open data on their website, which can be reused, for instance, for registries, for road signs, for registries, for mandates, political mandates. So the data is published. I think 605,000 decisions have been publishing and growing. Now, this as a context, and now I would like to give the floor to Georgia to share the findings of Marigraph. The floor is yours.
Thank you. Yeah, what you heard about Oslo, now we go inside the details of Marigraph project, where we try to apply this methodology in obviously Flanders, we participate in this project, but also in and see the practices in Italy and see whether there are some common parts and derive some conclusion about that. So just to mention the Marigraph project, here are the partners. By the way, many of them are here at SEMIC today. The idea, this project is funded in the DEP program, Digital Europe program, and the idea is to increase the quality of some of the data that are already available, defined as high-value data sets according to the Open Data Directive. And the idea is to increase the semantic interoperability, the technical interoperability, but also in the project we have thought about this organizational interoperability to think about the process and the methodology that allows us to do all these things for specific data sets. And we are speaking about open data once again, okay, here. So let's concentrate on this aspect specifically. The semantic assets are under construction. By the way, there is a public review of some semantic assets that we produced so far in the project. So if you want to contribute, you are very welcome. There is a GitHub of Marigraph project available where all these semantic assets are actually published at the moment. The objective for this specific aspect of interoperability we are looking at in the project is to identify a common process for the creation and the publication of semantic assets and open data sets that could scale at the European level. So starting from the experience of sharing these experiences from Italy and Digital Flanders, we would like to arrive to produce in the project some guidelines for a common process and methodology for creation of semantic assets at the European level, to propose also to the European Commission, okay, so that they can take advantage of this experience. That's why we are also interested, in hearing from you, actually. And this would also boost, in our opinion, also the data space creation. I mean, Digital Flanders has a specific task within the project also for data spaces. They are constructing data spaces. They are good in this, okay? So they are constructing data spaces in their country. We should do, by the way, I'm looking to some colleagues of the Italian government that are sitting here. And so I think that definitely it's important also for the data space. And the scenario is the following one. So the Digital Flanders in Belgium has a very well established, as you heard before, very formal process rooted in Oslo. Okay, Italy. Let's say we participate as the CNR. CNR is a research institute, the biggest research institute in our country. Let's say, applies a scientific methodology that is published in the scientific literature. It's called Agile Extreme Design with Content Ontology Design Patterns. So you can find it, there are papers describing it. And to be honest, since I still collaborate with the Italian government, and I have done many semantic assets in my previous career also for the Italian government, this methodology has been applied also in that case to produce ontologies for the public sector that now are in our national catalog that will be explained afterward in this session. So the approach here, which is the approach, so we have two different countries, and what we want to do is to work together to identify common unified factors, of these two different methodologies that we apply when we create semantic assets, for example, and then we publish data according to those semantic assets. And actually, there are some common unifying factors, and we would like to, in essence, describe it. So this is the process that we are now following in Marigraph, okay, which is a general process, I would say. This is the first part for creating semantic assets. So we defined and we published the so-called charter, okay? If you are familiar with the process of standardization bodies, is very similar to that and derives this from the Oslo methodology. We identify so-called use cases and what we call in the other methodology, scientific methodology, competency questions. So questions that you want to pose on the data that you want to represent with semantic assets so that semantic assets can support, okay, the answer to those questions. We identified, obviously, existing standards, as in the previous slide that Evelyn showed. Also, we identified so-called ontology design patterns. I also mentioned this morning in the other workshop. These are already available modeling solutions for recurrent modeling issues that you have, and sharing these patterns allows you definitely to enable interoperability between semantic assets. We ask feedback because we have always human in the loop, and we start asking and engaging with users interested in these semantic assets. Then we produce a source code, okay, of the ontologies. In order to do that, we identified controlled vocabularies. We included metadata for these semantic assets, because it's important also to provide metadata not only for data sets, but also for semantic assets. We want findability, also for semantic assets. We publish it in technical repositories. We defined GitHub as a repository to publish semantic assets, and we open a public review to engage with end users. For the linked open data creation and publication, we start from the semantic assets we created to define also shackle shapes for profiles and to validate things, okay? Validation is very much important, and we are starting leverage also some cardinality restriction, let me say, that we included in semantic assets. And then we created the automated process to create data sets against those semantic assets. You can use whatever you want here, okay? So you are free to use RML or any other kind of way to do that. The important thing is to automate this process, obviously. Then what we have done is to include metadata to document these data sets. DCAT AP, it's the basis. Then there are the national extensions. We have also, both in Belgium and in Italy, some specific national extension for that. With the final desk, this morning there was a workshop on that, based on all of these, and we published that data sets in Aldes and in Sparkle, okay? And then, once you have this, you can enable then the harvesting to national and probably also international catalogs of data and semantic assets to be findable, in a certain way. So this is actually the process that we have applied, and we learned few things, okay, we want to share with you. There are 3 dimensions very important for us: the governance, technical aspect, and user engagement. And let me share some lessons learned regarding these 3 dimensions. Belgium has a very strong governance, okay, in the sense that they do everything in a very formal way. In Italy, it's slightly different. Probably it's the difference between North Europe and South Europe, I would say. But at least also in Italy, we have a governance, okay? We have here the Department of Digital Transformation of Italy, which is part of the governance of these semantic assets, together with the National Institute of Statistics. So we have a governance, okay? But for example, we noticed that starting from the charter, starting from the idea to create a semantic asset, probably in Italy doesn't work. In the sense that, at least in our country, public administrations are quite free to propose their semantic assets. So they arrive to us saying, look, I have done this in a project, okay? I would like to be included in the national catalog of semantic assets. And so we just consider the semantic assets to be included in the national catalogs based on some requirements, obviously. So there is a more freedom, let me say, in Italy with respect to Digital Flanders and Belgium. And what we noticed also in the project that the charter sometimes change quite quickly, because in the charter you start with the objectives, the general objectives, you propose a plan with this co-creation stuff with the users, but then we noticed that we were there changing different times this charter because the plan all the time are disregarded. So that's our experience also in practice in applying this methodology. So the consideration is definitely we need a governance, okay? We cannot do that without a governance, okay? So we need to set up a governance and probably balance, okay, with the very strong formal governance with the more degree of freedom for public administration, also according to their needs and requirements. From a technical perspective, there are many comments. Actually, I would say that the process that you have seen before works with tools, okay? It's important also to engage with users and automate the process, you know, to have tools in drawing your semantic assets, in producing the source code, in publishing them, in also have some tools that allows also non-expert user to read these semantic assets. It's not only the source code in OWL or RDFS that count, but is also, there should be like a way to navigate these semantic assets in a more easily user-friendly way. So tools are important, definitely important. As we found, for example, that is important also to use foundational ontologies. I know that this is some tricky stuff, but we understood that if you use foundational ontologies, someone call it the 6 stars, okay? The 6 stars model, okay, after the 5 star. It's important to, if you connect ontologies between each other, and if you want to really understand what you are modeling, okay? It's something that we also learned here. As we learned that only searching for terms in existing standards, something that I already said this morning, is not sufficient to define a semantic, okay? We need more. We need to, as I said before, use a so-called pattern, okay? Like we do in software, by the way, when we develop software, you know? It's the same, because it's the same process, actually. And this is rather important also to enable interoperability between different semantic assets. Consideration. I would say that is one of the most important considerations is that, for example, in Italy, we don't have a specific process that impose some drawing of, for example, of the ontology. While Digital Flounder, they start from UML, okay? This is one important point. And nothing works if you don't start from UML done with Enterprise Architect. This didn't work, okay? This didn't work in the project and didn't work for us. We use different tools. UML is done for some purposes. It's not expressive as some semantic standard, you know. We use different tools more close to represent graphically a semantic asset, more close to representing ontologies, for example. So our recommendation here is importance of the tool, but not constrained to a specific tool, especially if it is not open source. This is also a message for the European Commission, I would say. The second aspect regarding the technical part, this is something that we discussed also yesterday. We had the General Assembly of this project. We found also the URI policy. That's really important. We found that we follow the same guidelines at the European level, but we have different way to apply in Italy and, for example, in Digital Flanders. I think that the most important principles of having persistent URIs should guide you, you know, when you define your URI policy. But don't underestimate this step of defining a URI policy, because I have experience with public administrations. They just think at the end, and then they don't think about the persistence. They want to put the system, or they want to put in the URI, the organization, it's mine, no? It's, and I say, don't follow your ego when you create URIs, okay? Try to be as neutral as possible to do that. And another thing that we learned from Maregraph is that if we provide access to the producer resources in different ways, and here comes not only Sparkle, but also LDES, for example, we can maximize the reuse. So this is another experience that we can definitely share from this project. Obviously, validation count, that's why we introduce in the process shackle. And another important point is provide metadata, not only for data set, as I said, also for semantic assets, because it's important to document from findability the data set and the semantic assets. And this is one of the last recommendations. Yeah, the importance of the role of catalogs. Going to the end, user engagement. This is a very difficult task, okay? We found so many difficulties in this project to engage with users. Probably is a very, how to say, it's a very vertical project on a marine knowledge graph and marine environment, but it's really difficult to engage with the user. But we believe, all of us, that is so much important to engage users since the first phases of the project. Also, doing public reviews is important. In Italy, we have a law that regards technical guidelines, 1 month of public review, okay? In Flanders, they have 3 months, okay? So we found like a trade-off between this time also for the public review, but it's really important to have public review. We also reasoned about the fact that okay, the public review, it's okay, but then there is also maintenance and the user engagement, continuous user engagement that could be very complex. So, just some question for you. We would like to do some questions, okay, to the audience, okay? How do you want to organize this?
In case I've also put together a survey where people can fill out the answers because we're really interested.
Do you have a link to the survey?
Yes, I have a link if you go to after this one. Yes.
So maybe people take notes.
Yes, so the aim of maybe a few minutes, 1 minute about the survey. What the aim is?
Sure. You can.
Yes. So we would like to invite you all to give your feedback on what we have been doing. If you have any ideas or things how we can foster collaboration, because now we have done a collaboration Flanders and Italy, but we also invite you to think with us and to come up with ideas how we can foster this collaboration on tooling, methodologies, processes for the publication, but also afterwards on the updates on the semantic assets. So please go to the link and fill out. It's only 10 questions, so thank you very much.
So thank you so much. The way we organize the workshop is that we've asked each of the presenters to have 1 to 3 statements about what they think is or what summarizes their opinion between the content of their presentation and semantic interoperability for the public sector. And we're using Slido. That's why I told you at the beginning it was important for you to participate. On Slido, we are now publishing the questions, and you can express your strong agreement to strong disagreement about the statements. So if we can push the Slido page, everybody is invited to participate from say home and in the audience here. Can we also put the web page where the web page, and we will push the question. This is the previous event. No, this is don't scan this QR code. This is the one the event that was in the morning. Let's see. For those who have accessed with the other QR, this is the right QR code, and you would see on your mobile phone the statements. Is it working?
So we go to the polls?
Yes, there is. All right, okay, so exactly, okay. Now, I see that the votes are coming in. We'll give it to 30 to 60 seconds for each of the statements. In the meantime, I'm removing this because it's creating issue. Let's see, maybe other 10 seconds. We will use the results at the end with the panel. We'll go through the results again, and anybody here or remotely would give a comment whether they strongly disagree or agree on and why. And we'll have our experts to maybe give a reply. We can go to the second statement. You can continue vote even if the statement will not be on the screen. That is true for everybody. So thank you again to our previous speakers. That was the best presentation that would transition to the second part of this workshop, where after seeing how a governance applied to the creation of semantic assets with work and the benefits that it will bring, it gives me also the opportunity to mention that as SEMIC, this past year, we have initiated the work on a EU-wide registry of models for the public sector. This would be the opportunity for each member country who has already a national repository of semantic assets to be connected to a registry which will allow all of the other member countries to search and find semantic models during their process of designing a new one. And this is because we want them to not start from zero, but to import parts of models that already exist, or to import or to use an existing model and then extend it. And this would really much put the basis for a level of cross-border interoperability which we are searching for. We should go next to the other speaker, Ed Curry. Yes, it's you. Yeah, so the slides for Ed will come. So Ed will give us a peek into the future of what are the opportunities for cross-border and domain interoperability. Thank you, Ed.
Thanks, Claudio, and thanks very much for the introduction. My name is Ed, and I've been researching kind of data space technologies probably for the last decade or so, and I'm involved in the Insight Center for Data Analytics, Big Data Value Association, the AI Data and Robotics Association. And today what I want to talk to you about is probably some of the research that we do at Insight, and then particularly some of the kind of, I would say, big picture things that I think are important in this area when we think about interoperability in the broader sense. So some of the stuff that we do at Insight is in relation to the Data Space Support Center, and Johannes will talk a little bit more about that in detail, so I shall not steal his thunder and his good slides, but we're involved in a lot of work there in the areas of best practices, semantics, standards, etc. But some of the work that I will talk about is some of the more research kind of focus work that we do in Insight on the areas of kind of foundation data space models, the uses of knowledge graphs, and kind of bringing together these different life cycles, and really understanding what it means to be a data space and what interoperability actually looks for. And a lot of this is built on some of the work that we've been doing in deploying data spaces in kind of research environments for the last decade. So the first statement that I'd say today is that cross-border data spaces need a data coexistence approach. So I'm going to challenge you to say that actually interoperability is not the goal, but rather coexistence is what we need to start thinking about. And I'm going to try to convince you of that over the next little while. I'm here to be provocative. That's why Claudio brought me. So here's a diagram that we have that talks about basically the type of data that we have. So we talk about this notion of long-tail semantics. So you have all of your entities, your data sources, your attributes here on the bottom of the graph. And we have this long tail where we have some of our entities are used quite frequently, the attributes are used very frequently. We have this very, very massive long tail that's very, very challenging to deal with. And what we've seen over the last decade, and actually since the start of computing, is that this long tail keeps increasing. It keeps increasing because of the types of data that we have, the quantity of data that we have, the more data that we're able to model and to explore. And the challenge that we have here is that as this continues to grow, the cost of mappings continue to increase as well. So if you look at the traditional approaches that we have, so this is the frequency of use of our data. These are basically the costs of basically mapping data or integrating data. And what you see is that the cost of those traditional approaches increase exponentially. They're not designed to cope with millions of attributes. And even today, some of the examples we've talked about, and earlier today as well, people are talking about 80 data sets, 1,000 data sets, 2,000 data sets. The challenge really today exists in millions of data sets. And when you start thinking of those numbers, you realize that this is very, very challenging to scale. Doesn't mean that it's not useful, doesn't mean that it's not important in terms of quality and accuracy, but we do need something else to deal with the long tail because these technologies themselves are not fundamentally designed for that. What I want to talk to you about is, I want you to think about interaction paradigms, and I think we're at the start of a change, a fundamental change in how we interact with data. Does anybody recognize this? I've got a lot of gray hair. Okay, we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, about half the room recognizes this. For those of you that didn't know, back in 1995, this was the center of the world for all of us in computing. This basically was what the internet and the web became. And really, this changed everything. This was Yahoo. It was the first directory of the web. And if you wanted to find a really good website, I'm a fan of Liverpool. I'm going to watch the Belgium game later on. Claudio will have to figure out the logistics of this. But if I wanted to find a web page about Liverpool, I'd go here, I'd find sports. I'd have to click on soccer because Yahoo was a US company. And eventually I'd find English League and then Liverpool. And I click on that link, I get a beautiful list of high quality websites that were all about Liverpool. This was amazing. It was absolutely fantastic. And this Yahoo was one of the biggest companies, if not the biggest company in the world at the time. It was that significant. Unfortunately, Yahoo doesn't exist anymore. We'll explain why. But this was 1995, and roughly there were 100,000 websites in the world. Okay? Not that much. The beauty of this is that it gave you exact results. When you clicked on this, it gave you high quality results. You were very happy with it. The downside is that it was human curated. If I was creating a Liverpool website, I would have to actually post to Yahoo to say, hey, here's my website, take a look at it. Yahoo would take that in. They would actually check it out to make sure that it did fit into their taxonomy, and maybe it should have gone somewhere else in the taxonomy as well, and they human curated. But that's the secret for why it was so good, is because it had very significant human curation going on to ensure it was put in the right place. A mere 3 years later, we went from 100,000 websites to 2.4 million websites. So exponential growth of what was there. And this fundamentally changed the world again. So I'm sure everybody recognizes this. This is the primary paradigm that we have now today for information. And the key thing here was that we didn't need to understand the taxonomy. We didn't need to understand the semantics of that taxonomy. We didn't need to know that soccer and football are actually the same thing, or maybe they're not, depending on what you're thinking about. But what I could do is I could just type in Liverpool Football Club, and I would get back a list of results. The key thing here was that these were approximate results. They weren't exact results. They're a list of search results. They gave me back useful information, then I could figure out what I needed to do. And the magic of Google was that it was actually computed. So they had PageRank, TF-IDF, all these wonderful things, not all invented by them, but basically they were able to compute this. They didn't need to have an army of people going over this taxonomy, making sure everything was in the right place. And fundamentally, this scaled. This didn't scale. We don't even know what this is. Half of you don't even know what this is anymore. Everyone knows what this is. So there's a fundamental change there in how the paradigm shifted to how we interact with that data. Fast forward a decade or so later, the web had gone from 2.5 million websites to 700 million websites. And what interestingly happened here with Google is that people were actually less interested in web pages. What people were typing into Google were not keywords, but were actually questions. They had questions that they wanted answers to. They didn't care if it was on a web page. They wanted those answers. Google recognized that. They took Freebase, took it private, got themselves an army of curators and built this knowledge graph that basically now would actually complement the approximate search results with these high quality facts that had been curated. So you had this blended approach of computed and kind of crowd, approximate and exact results together. And this is kind of the primary paradigm that we exist today. And again, the key thing here was that after You go from 2.5 million to 700 million web pages. The web page is not important anymore. It's actually the information, the interaction has changed fundamentally. And I think now we're on the precipice of actually seeing another fundamental shift in how we actually interact with data. 2 years ago, 3 years ago? 2 years ago at this stage, 20 months, somebody said this morning, ChatGPT came along and it fundamentally changed in how we actually think about data. No longer are we even interested now in answers to questions. I need to write a report. Maybe some ChatGPT can help me write that report, as many a student has never said in my class. But you know, you can see there's a fundamental shift here. It's no longer about figuring out where in the taxonomy the data is. It's no longer about figuring out what the answer to the question is. But it's actually, well, I need to write a report that analyzes the effects of certain interventions in the healthcare system on a particular population. Can you help me write that report? It's moved at a much, much higher level. So I think what we're really looking at here is moving to the world. Anyone remember this guy? Hands up. It's about the same as the Yahoo answer. So this is Captain Picard, and on the Enterprise, he used to talk to the computer. He'd ask the computer questions. Computer, figure me this out, figure me that out. It was a conversation that was had. There was no typing. There was no writing SQL queries. There was no worrying about persistent URIs. It was a conversation about information. And the assumption was that the computer had all the information. If it didn't, it would tell you, and that was it. But it fundamentally shifted the interaction paradigm. And I think we are very, very close to that. We're starting to see the beginning of that. Now, it might still take another 5 or 10 years to get there, but that interaction is changing. And fundamentally, what this means is that we need to think about what's our relationship with data sources and what's our relationship trying to manage those data sources. So if we go back to that notion, and this is pulling off the original paper on data spaces from Halvey and Franklin, 15, what year is it? 2006, almost 20 years ago. So I'm really going back to the kind of scientific underpinnings of this. But they've done a really nice analysis of this in one of their papers that talked about the notion of administrative proximity and semantic integration. And on one of Claudio's slides today, he talked about autonomy. And that very much kind of ties into this. When you look at the administrative proximity of sources, what level of coordination can you expect to have over those? Do you have close or loose coordination? In terms of semantic integration, to what degree do you actually expect your sources to be aligned, or do you just expect to get different sources together? And the examples, like the extreme example that we give there with web search, is that we actually have very, very loose administrative proximity. Yahoo only controls their websites. They don't control the 100,000 websites that were there, or Google doesn't control the 7 million websites that were there at the time. But the level of semantic integration is low. When you do a search result, you don't expect, at least in the tradition Yahoo, you don't expect for those results to be integrated. What you have seen, though, is that Yahoo or Google today has started to move more towards this, where they do actually have more integration of sources with their knowledge graph. But it's still we wouldn't say at the same level as a database management system, where you expect to have full control and you expect to have full semantic integration of that. Interestingly, I think open data portals are kind of sitting around here. They're not the same as a web search. There are some ontologies that are there, but what you see is that a lot of them aren't using the same ones. So the level of integration isn't there. Even though they are using standards, they may not actually be semantically integrated. The questions that I think are open when it comes to looking at data spaces and when it comes to looking at cross-border interoperability is where do we fit here? There's different philosophical views on this. Some are very much down that a data space gives you the same level of control and coordination that you would have in a database management systems. More are kind of over here to say, well, actually, there's less administrative control, there's less expectation of semantic integration. I think that's an open conversation, and I think that's something that's going to be dependent on each domain. So, for example, some domains may be able to achieve that, other domains may not. It also depends on the scale that's there as well. But I think it's an open question for us to explore. The other thing to think about is this notion of what's good enough. Okay, so the enemy of perfect semantic integration, well, actually, perfect integration is the enemy of semantic integration, is the best way to say it. A lot of the times, good enough results are all that you actually need to be able to perform your task. So this is actually a really nice article from Pat Hallam that talks about that the majority of decisions that you make, if you have 80% accuracy in your data, is probably sufficient for that. Now, it's not sufficient if you're flying a plane. It's not sufficient if you're doing heart surgery. But for a lot of decisions that you make, you do not need 100% accurate information. And the reality is, in your current databases, you don't have 100% accurate information anyway. You're just not aware of where the inaccuracies are. I had a quote from Obama that I took out of this, but he talked about when you're making a decision, if you feel you have 51% of the information available, that's probably good enough. And that was very interesting for a person that had to make multiple critical decisions every day and not be able to kind of spend a lot of time on each one of them. So I think it's an important thing to look about this. So then we come back to this notion of, well, what is a data space? So this is the original definition from 2006. And what's really interesting with this is that they talk about the data spaces are not a data integration approach. Rather, they are more of a data coexistence approach. The goal of the data space is to support and provide base functionalities over all of the data sources, regardless of how integrated that they are. So if you're thinking of Yahoo as being that fully integrated model versus the search model or the search plus knowledge graph model, where you have more of a coexistence of those sources together. And I think that's something that we need to look at when we consider the long tail, because when we're looking at this long tail, our existing Yahoo-style approaches, while very, very valuable and very, very important, particularly for critical decision-making, are not going to be able to help us support the long tail. So by looking at more of these kind of best effort and approximate approaches, I think we can actually tap into the value that exists within that long tail. So that's the need for coexistence, and we need to think about how do we get our data to easily coexist with other data. The next statement that I have, which is a little bit shorter, but the notion of cross-border data spaces will need a marriage of neural and symbolic approaches. So when we talk about models, a lot of us here are talking about data models. If you're in the sessions this morning, we'd have been talking about AI models. Okay, so it's important that actually the world exists with both of these. Looking at the original paper again from Halvey, to have this notion of coexistence, your data space needs to be able to deal with many different formats of data. So you're not trying to canonicalize everything into a single format, but rather looking at the existing formats and working with what's there. You're not trying to subsume existing systems, but rather provide individual access to those interfaces. Queries are provided on a best effort, approximate basis. And the idea is that you're trying to provide pathways for how you can incrementally improve that data over time, which very much kind of goes back to the 5-star kind of perspective from Tim Berners-Lee on linked data. What this kind of says to us is that when this was written 20 years ago, this was a very challenging perspective, particularly when you think of it, Google was effectively, it was a Google mindset that was here, but from a database point of view and from an information management point of view, we didn't necessarily think we had the tools to be able to deal with this. A lot has changed in the last 20 years, particularly when it starts coming to the use of LLMs and to the use of neural networks and knowledge graphs. And what we've seen is that actually these tools and these techniques are actually providing us with the ability to actually start trying to implement some of those ideas in a more fuller way. So but by looking at both our traditional knowledge graphs and then understanding how basically LLMs, foundation models can actually support and help us to manage data, I think we can actually try to tackle that long tail with very, very specific types of support services to do that. To give a quick example of what that looks like, so that the notion of, we talk about foundation data space models. So if you have a data space, for example, a mobility data space with or a public sector data space with all of the different types of data that would exist there, by analyzing that data, training it, you can train yourself a foundational model and then basically adapt that to different types of tasks that are needed to be able to actually operate and to be able to run that data space itself. So it's a way of trying to leverage those techniques together to be able to manage and to be able to operate the data space. Again, it's early stage stuff in terms of it's still at the research stage, but when you look at the work that's out there already, you can start to see the kind of early green shoots where this starts to make an awful lot of sense. In terms of the Data Space Support Center, which Johannes will talk about later on, we've identified a number of different building blocks there. And one of the exercises that we did from a research point of view was to look at those building blocks, and if we were to ask ourselves, where could a foundation model, a neurosymbolic approach or a generative AI approach potentially support some of the activities that we've identified there? What we see is that on the technical building blocks, there's lots of opportunities to do it there, but also in the business and the organizational interoperability, there's lots of opportunities there for these models to be able to support and to be able to implement those approaches. So I think the key thing here is that one way to be able to scale interoperability for cross-border data spaces is to start using neurosymbolic approaches, LLMs, to help us to do that. And then finally, the key thing when it comes to generative AI into data spaces is this notion of the killer app. So understanding that these particular tools, if you consider the context of where they're going to work, and like if you look at, like, for example, the Macs and the desktops, VisiCal was the main killer app that actually existed there. For Windows machines, we had Microsoft Word. That was the main thing that drove people to actually buy Windows and kind of Intel-based machines. Netscape was the killer app for the web that fundamentally brought us to Yahoo. And the App Store was the killer app for mobile phones. Before that, it was just a phone, suddenly became a smartphone, suddenly making phone calls was probably one of the least things you actually do on your phone today. And I believe fundamentally that generative AI foundational models will be that killer app that we need for data spaces because they can leverage the value that exists there. And then finally, the last point I'll make is that we need a unified lifecycle between AI and data, so that when we are talking about data models, we're also talking about AI models at the same time, and understanding how improved data governance can actually help us have improved AI models as well. So the notion here is that you have our data spaces and foundational AI, and data spaces can provide this high quality data within a clear governance framework, and at the same time then we have our generative AI models that can actually help us extract value from that. This is a quick, I won't go into the detail on this one, we're out of time, but basically looking at unifying our data management lifecycle that we'd have within a data space with the process of actually developing and deploying AI models. So by bringing both those life cycles together, we make it kind of clear that they work. We make it clear how improved data can actually help improve our AI models and how AI models can help us manage our data. And then finally, on that point, there is need for more end-to-end management. We have DCAT, which is a wonderful tool that many of us are using, but we need an awful lot more standardized metadata. Not standardizing all of the data, but just looking at the metadata and the role of that within it. Final thought from me, when it comes to data, anybody familiar with Alice in Wonderland and the Red Queen? So if you're into evolutionary biology, the Red Queen hypothesis was inspired by this notion that the Red Queen, she would always be running just to stand still. And in evolution, you have to be running to stand still, because if you actually stop evolving, you die. That's kind of your evolutionary hypothesis. When it comes to data, data is a Red Queen. We have to keep running. It feels like we've never been able to actually manage and to control all of the world's data. And that's because there's constantly more and more data being created. So we're always going to be tackling these challenges, because the quantity of data, the variety of data, the amount of data that we need to work with will always be increasing. And with that, that's my 3 statements. Thank you very much, and I'm looking forward to the conversation later on.
Thank you so much, Ed. Thank you so much. Hey, awesome stuff, awesome stuff. Sander, we should be proud of the people we invited. This is very advanced. But so, okay, let's switch for a moment to the question, to the statement that Ed has prepared for us very quickly on the screen and on the Slido, so you can put there your preference on the level of agreement you have. And yeah, if there is something that caught my attention from Ed's presentation, is really much the idea that mapping will not scale, and this is a lesson in that if we autonomously, independently develop our models and then we try to map them all together with the amount of models that are out there, it becomes impossible. And so there's even one more reasons why we should aim for interoperability at the very beginning of the process. Either whether we do it like a very strict governance, or whether we do it with a more independent way of designing, by being inspired by the work of others. All right, some votes are still coming in. And we want to go and see the match, I understand, right? So in the interest of everybody, yeah. Let's stick with the time. Let's move to the second statement. You can, if you can also stay neutral if you really don't know where to position yourself. And once again, we will use this with the comments of the speakers later on in the panel. Now, for the 10 last seconds of gathering votes, I want to invite our next speaker, Johannes. Is it Johannes now? No, Maria Poveda from UPM, and she will talk about what does it take to reuse and why people do not reuse, and how to chase them and beat them in the head because they don't reuse. Yes, thank you, Maria.
Sarah, you put the slides?
The slides are coming on the screen,
okay.
and you can move them with
Thanks. Okay, so, well, actually, I'm going to agree with the first presentation all the time, so as many things have been said, I will be faster because I'm between you and your coffee. And yes, I'm Maria Poveda, and I'm an associate professor at Polytechnic University of Madrid. I'm a computer scientist, so I know all the programming and computer stuff. But what I do in my research is to try to hide all the difficulties from the ontologies so that other communities can develop them and reuse them and make linked data at the end. So I try to democratize ontology development in my research. And part of this, okay. Yeah, well, I'm going to skip the part about which kind of ontologies we are talking about. Of course, I refer to all ontologies, and we follow the W3C standards. And the idea is that we make or we explain to the computer what we think and the concepts and the relations that we have in our mind when we are talking about one domain. Yes, and why, and this workshop is about reusing ontologies in principle, but then I saw the description and said, okay, now I want to talk about many things that was included in the description of the workshop, but I only had 20 minutes. Let's first focus in the reuse part and then the others. So the big claims for ontology reuse have always said that it increases the interoperability, because if you reuse someone else's ontologies, the data will be more or less interoperable by default, and also that it reduces the development time and resources, because you are already taking something that was already built. These slides are also from, maybe you remember from last year, in which situation do we need to reuse ontologies? So for example, in all our projects, European projects, projects with companies, private projects, and very kind of small development for a very specific data sets. For example, in our project, we normally try to align with ontologies from the ones that are in JoinUp, also the ETSI, that are the SAREF ontologies for IoT and sensors, and of course the W3C ontologies, because they have gone through a standardization process. But we are also building the SAREF ontologies and extensions, so when we are building these standards, we also need to reuse the SAREF core to extend it to different domains. For example, yesterday I was committing the SAREF for industry and manufacturing, because it is going to be a new family. For all of them are going to be new like in a couple of months. So if you plan to reuse SAREF, wait some weeks so that you don't lose the time. But also there are, for example, in some projects there are open calls, and then they build some ontologies, and those applying for the open calls need to reuse the model. So again, you need to know what someone else has done. Okay, the screen is done. It's gone, but it doesn't matter. So the first thing is, this is a bit technical, but the first thing is we need to publish the ontologies. And it is, for us, if you come from the semantic web community, it's so obvious for us that we define URIs and we make it the referentiables. And one thing is the URI, that is the name that we give to the things. Another different thing is where it is stored. So your ontology is not your GitHub URL repository file, that is a URL. So there are already guidelines that tell you how to encode your server so that you do this content negotiation thing. Actually, in this
book chapter, there are also some technical recipes that you can copy and paste. And also there are guidelines, quite old indeed, for cool URIs, that is the URIs, the names that you give to your concepts and your properties, shouldn't be changing with the time. That is why they are cool. And there are systems that help you to do that. Imagine, you don't need to buy a server and to pay a domain all the time. You can use, for example, this W3C ID server that redirects to whatever file system you have online anytime, to redirect the URI that doesn't change for your ontology. Okay? And that is something very basic for us, but every time you enter into a new community, you need to give all the first pointers from how the semantic web works, because otherwise the first thing that people say is, we need to build no, there are many things that are already built and we can reuse it. Some lecture on reuse, because I'm an associate professor and I can't avoid that. How do we make the reuse? So in the semantic web, there are two ways. So if I'm building, for example, this ontology, the one in ontology 1, so I can be defining my own classes and properties, or I can be reusing this onto 3. I just use the name, and that name with the whole definition will be somewhere else on the web, and I just say, okay, I'm reusing that concept. So I don't need to invent a new technology to reuse ontologies, because the web already works like that. And that is soft, we call it soft reuse. You are just referencing, but you can also say something else about that. I can reference someone else's ontology and say that my class is exactly the same as the other class. So we both are defining the cities, and we say, okay, well, this is equivalent, and when you run a reasoner, there will be equivalent. And that is already thought in the web. But there is, imagine that you want to reuse a whole ontology and say, okay, I'm not going to copy everything in my code. That will be difficult to maintain. Then OWL provides you with this OWL import. And then in the OWL import, you tell the system the ontology that you want to reuse. If the ontology is nicely published, following the links that I gave you before, when I ask for this URI, everything that is in the other ontology will be part of mine. But it's not going to be part of my code. In my code, only this statement, this repo is going to be visible, but everything that can be retrieved online in running time will be incorporated. So all the logics and the rules will be incorporated as well. And we call this hard reuse. So when you are reusing, you have to think, okay, do you have a strong commitment? Then you reuse the whole model, or you just want to point to someone else's ontology and extend or add more rules or definitions about what you are reusing. Think that if you are doing the hard reuse, if the original ontology changes, you will not be notified if the versions are not identified in the URI. So if you have version in URIs, then you can point to a specific version. If you just have a canonical URI, if that canonical one changes, everything will be changed and you will not get any notification. You will realize somehow later, okay? And for the other kind of reuse, okay, if the ontology goes offline, it doesn't happen because you still have the reference, but there will be no further definition after that. And if you copy parts of other ontologies in your ontology, if the original changes, it doesn't matter because you keep a copy, actually. So there is no better and worse. In each case, you have to decide what you want to do. Yes, I think. So the idea is that, of course, in both cases or in the semantic web, the ontologies can become unavailable. And yeah, that is true. That is a pity, but the web works like that. Also, the website become unavailable, and we don't cry all the time about that. So this is exactly the same. And yes, we need to publish them properly so that people can reuse them properly, but we also have to advertise or to have a common point, because maybe asking just the search engines are not enough. Then LOV, the Link Open Vocabularies, is one of the registries that you can use to look for ontologies and to enter your ontologies. And yeah, it was developed by a French project in 2013, I think. And I'm not really good with this. And yeah, the project finished. We wasn't part of that, but because it was French. But the resource was very valuable for the community, so we adopted that and we keep it and maintain it at UPM. So if you, and also Ghislaine that is around is also maintaining the service. So for each vocabulary, we have really minimum metadata, and we ask for just few fields of metadata to authors. We don't ask much. And then this is an example of you can find like namespace. Namespace is critical, and the URI, because in other registries, you get everything, a lot of functionality within the registry, but there is no way to find the original code. So I want to go to the original code, and I want to see the original URI. You also have the statistics about who is using this vocabulary and how many classes and properties, in case you are interested. And one very nice feature is that LOV stores the versions of the vocabulary. So if it goes offline, maybe you don't want to reuse it, but you can have a look at the versions and reproduce the code. You can copy a way of modeling things without copying the code, just getting inspired. And there are some connections with other applications. Of course, if you include a term, it looks for the classes and properties that are closer in their definition to your search and gives you all the vocabularies, and you can also filter by topics or whether you are looking for classes or properties if you already know that. Yeah, and there are many other kinds of registries. For example, Bioportal, that was the original one, has also AgroPortal, Industry Portal, and there are many portals that are now being federated in the Ontoportal Association. They have many functionalities inside for curation. For example, for us, for each project that we build, we like to have one portal for the project where all the developers and stakeholders can find the ontologies, the GitHub repos, the SACL shapes, the JSON payloads, everything. I didn't mention, but also this one is the Saref portal, where you can find the Saref ontology for IoT and all the extensions. Yeah, so that was about increasing interoperability, how to do things, where they are, and the other part was reduce development time and resources. So in theory, there are also works that tell you how to reuse ontologies. Good luck with that. If you have the perfect recipe, I haven't found it in like almost 20 years. And yes, the carrot is always the reduced development time. For me, that's not really true. So at the end, I spend more time trying to understand someone else's ontology than if I build that from scratch. I know what I want to model, and I will be faster. But then I will lose the interoperability part. So for me, this claim haven't really been proved so far. So in many cases, there is no documentation at all. Here is my RDF. Good luck. Open that in Protege. There is no documentation. When you have documentation, it's not that good documentation because I just have an HTML version of your RDFs. So it's the same, but in a nicer way with hyperlinks. And there are no diagrams. And for me, it's like, okay, if I open an ontology and there is no diagram, no. I'm not going to read that in a good mood. By the way, we are always talking about the standards in this community, and we don't have a standard for drawing ontologies. And if you are lucky and find a diagram, then look for the legend, because there is no way someone put the ellipses, other the squares, other something else, and be creative. And of course, there are, if you find examples, there are these little small examples to populate the ontology. Of course, only a few people publish the requirements together with the ontology. Actually, we were looking at this and wrote this paper about why the ontologies are not reused, and I found that. Also, it was important heterogeneity between the concepts. For example, In Spain, we have 2 types of associate professors that has different names. Then if we want to have a academic ontology in 2 countries, the concept don't match semantically. And also heterogeneity in the language. Maybe you find an ontology, but you cannot reuse it because you don't understand it. And of course, the documentation, and that we publish the resources without a license. Then in principle, it cannot be reused. Yeah, this is what I mentioned, that I agree with you, and I say, okay, I need to add many resources here that might be useful for the people. So this is our methodology that we follow for building ontologies. And these are like the main tools that we are using in each step. But if you go to this website, and this paper is the same, is the methodology explained, and then you have the full list of tools that you can use for each step. So the important thing here is that what I like more is that we don't put the reuse after the requirements, because if you look for ontologies just when you have your competency questions, that will be there. You will have so many results when you don't know yet what you want to model. So you will be analyzing all the other ontologies and say at the end, I don't know how to choose between them. So our idea is that first we make the conceptualization more or less where we are looking for. And once we have it more or less clear, then go to the reuse and come back to the conceptualization. And actually, how do we do the conceptualization is using this system. It's a notation that is called CHOC. CHOC is a very bad pun. CHOC notation that is a UML-alike version for all ontologies. So in the arrows, you can explicit all values from, some values from, whether there is a domain or range. And what I really like is that in the diagram, I can state properties between the classes that I intended to use it among, but there is no domain and range. So that makes a difference, because if you go to the code and you see a property with a domain and range, you have no idea about how to use it. But if you have a version in the diagram saying, okay, I expect to use this property between individuals from this and individuals from that, you are telling the person how to use it. But in the code, there was no clue to know about that. So there are some things in the notation that are more to communicate about how to use the ontologies. Yes, I also saw in the description of the workshop about the quality of the ontologies that we are producing and the absence of pitfalls. And then I say, okay, I have to talk about OOPS, because OOPS is an ontology pitfall scanner that is also online. You can use it. If it doesn't work, just email me. And I will tell you why, but wouldn't fix it. And themis is to evaluate your ontologies according to your competency questions, making test beds. So it is like in combination with shackle shapes for the data. And of course, we use Guidoco for the documentation, but again, if you don't include the diagrams and the requirements and the example, this is just a HTML view, not much more than the code. And we publish, for example, I use this ontology that observes GitHub repository, so that every time I make a change, everything is run again, because it allows me to publish very easy ontologies with W3ID. I have it in my GitHub repo, and the W3ID just point there, and I don't need to pay either a domain and a server. And yeah, so we know how, more or less. So what I think that we need to get in there with the ontology reuse is about governance model, but I'm not going to talk much because it was also mentioned in the first presentation. So here there are just some examples about governance model as project level, and this is a private company summary of the governance model, and this is the European Railway Agency governance model. So you can have different models customized for different organizations or use cases. And this is the last slide from SEMIC last year. So I will agree more or less with all I said before, which is good. And my statement today is that, okay, we have not all the technology in place, because, for example, it would be nice to have like an ontology parliament, like, okay, in my data space, I'm using these ontologies, but then you have different data. Maybe we can have agents to agree on a common ontology for sharing our data. That is, of course, not done. Another thing that is not done is to merge different ontologies to produce a combined one. When I search for terms in LOB or other registries, I have to take pieces from ontologies here and there. And actually about how to reuse the ontologies, I think it will be great to reuse ontologies in a graphical way. So what I do actually is I reuse my chalk diagrams as a patterns, and start ontologies just reusing the graphical diagrams, because this is converted into code directly. So I just reuse the diagram. So what we really need is to make it easier, the knowledge transfer, because the problem is always telling someone else what the model means. Someone else from outside or within your company, when you change to another position and then the new internship enter, and you have to explain why you did model that. Also because people get retired and you cannot ask them anymore. And also that it is vital to develop the governance model within organization, but also considering the data spaces environment, that will be something broader that we will lead in dealing with soon. And that is all from my side. I think I'm on time.
Thank you very much, Maria. So indeed, this is second year Maria is talking at this workshop, and I've asked, also for Maria to have a statement, so we can put the statement on Slido. Actually, I've asked the speakers to be a bit controversial, but there's no controversy. This is completely true. I mean, it's obviously everybody's going to strongly agree with it.
No, maybe there are more technological needs. I don't know.
Yeah. Okay. Let's see what votes are coming in.
But I try to build as little code as possible. So that's why I say there is no need for more code.
Okay. Okay. If I take anything, and for the last 2-3 minutes before 1 minute before going to coffee. Indeed, I mean, it made me almost emotional, this presentation, because brought me back in 2005 and 2006 when everything is already out there. You don't have to invent anything. These people have, actually, Tim Berners-Lee should have been this year, but he said it's not coming. Anyway, the guy who invented this had thought about everything, and smart people with him had thought about everything already 10, 15 years ago. Reusing ontology is not difficult. And then there are some people that said, okay, ontology can be modular, so you can reuse a module. And then someone else came along and said, oh, you can use a pattern, so you don't have to invent anything from scratch. It is, obviously, this is very much RDF-based, so for anybody who doesn't speak RDF, it's a little bit kind of maybe cryptic. But I'm on the RDF church, so but so if there is any question, really, from Matthias, very quick questions, and then we can go everybody to coffee break. Just with.
Okay, so first a meta question. Will there be more questions and time for questions during the second phase of the after fika, or after the break?
Yeah, for the questions, we have the panel, yes.
Okay.
We will put back the statements, but if you have any questions that you have from the presentation, obviously everything is open. The panel is open discussion.
Okay, good. So my main question is that we are working a lot on DCAT AP. It's kind of a success. The application profile idea is kind of out there. It's something different. We've heard ontology for a long time during this session. We haven't heard anything about application profiles. We have only heard about assets. For me, an asset is something, I'm not sure what it is. For me, I'm looking into specifications, which can be all the way from something very formal, semantic, all the way to something that is just a dumb document, which Georgia mentioned also, that you cannot really force everyone to do something seriously semantic. You need to have all this span of different things. And therefore, I'm looking for what's your position on application profiles and also dumb documents as specifications. Can we accept everything? And then hint, hint, there is something called prof, which I'm advocating for a lot.
Yes.
Yeah. Do you mean prof? The
Profiles vocabulary is kind of a variant of IDMS to describe specifications and specification parts.
Yeah. So for the profiles, so I think it's about the ontology versus other assets and profiles. I normally use ontology or vocabulary as a synonym for a broad span or different semantically richer or poorer resources, from control vocabularies to very rich ontologies. And if I'm not wrong, I think the profiles for DCAT is something similar to the SAREF extensions, are like profiles from a core ontology to a particular domain or so. But at the end, like the easiest...
It's just reuse of classes and properties in new settings.
Yeah, so you reduce and extend to your...
Refinement.
For your use case, yeah. So at the end, the quick answer is, okay, if I save it, if it follows OWL or RDF's syntax, I'm going to call it ontology or vocabulary. And if I can run the same tools on top of it, for me will be more or less the same. And the SAREF, that we call it ontologies, can be called profiles, I think, perfectly.
Good.
All right, so it is time for coffee break. You're free to go. And I'll see you here again at 4.
All right. It's 4 o'clock. So let's get started again. I was just discussing with Claudio earlier that we were so happy that we were able to organize this, because then you can invite the people that you think will present interesting things. And I must say, I haven't been disappointed yet by the presentation so far. I'm very glad we have the speakers we have today with a very diverse set of skills and different looks on the kind of issues that come into play when dealing with cross-border semantic models. And that being said, with a lot of pleasure, I introduce Johannes, who will bring us his insights from working for the Data Space Support Center. He brings there his broad knowledge of semantic integration and data projects.
Thank you so much, Sander, for the kind introduction. Yeah, it's been an honor to speak about data space interoperability with insights from the Data Spaces Support Center. So first of all, I see the story of data spaces as some kind of sci-fi adventure. Data Space Wars, Return of the Semantics, where the scope of data, which is out there on the globe, is the galaxy, and participants in there might be seen as some planets in the galaxy who want to exchange goods in terms of data. And then there are big tech companies, which some kind of might be the trade federations, so they grow in size, grow in power, which is good in many points of views, but also not too good in some other points of views, might be the case. Then there are data spaces who promise to be trusty trade routes in this storyline. And there are semantic web experts or the SEMIC people who are here today and tomorrow on the conference, who might be the Jedis wielding lightsabers to connect all this together. And all these technologies we have might be the force that puts all this together. So why data spaces? I also go back in time, like some decades ago, there was the internet just connecting some computers. It grew to the web, more accessible to people, web browsers, more data websites coming up, and with Internet of Things and other trends, more and more data got produced, and at some point it gets really, really critical to actually still gain control over your data even after it had, especially after it has been shared with others. And this is some aspects that data spaces address with the promise to provide data sovereignty, which in terms can also be translated to the fact that you still have control over your data even after sharing it. Plus, why are data spaces important? They are some kind of a part of the European Data Act, and there's lots of money, of public funding going into this area, setting up these infrastructures. Now we heard about the topic of cross-border interoperability a lot today, and my talk will rather focus on data space interoperability, which is the ability for participants in a data space to seamlessly exchange and reuse data, either within one data space or across the boundaries or the borders of different or multiple data spaces. This is a quote from the Data Spaces Support Center Blueprint, one of their main glossaries, and all this is strongly aligned with the European interoperability framework that we have also seen multiple times today, like semantic interoperability, organizational, technical, and so on and so forth. So the goal of my talk today is the following. So I hope that I convinced you that data spaces are important for European Union's sovereignty. And of course, we all agree that there is some need of interoperability. And I want to tell you something about the role of data spaces in this story and some concrete solutions that actually address this topic. So the role of data spaces, there is the Common European Data Spaces that address data sharing, data management, collaboration, and so on and so forth across many, many different domains. And then there is the Data Spaces Support Center, a project that aims to bring all these domains more together to make them more interoperable in the terms that we just heard before. How do we do this? We provide tools, definitions, best practices, and so on and so forth to put all this together. By the way, thanks to Matthias Punter from TNO, I stole some of his slides about the Data Spaces Support Center because they just perfectly integrate into today's talk. And how does the DSSC concretely do this? From this vision, we derive very concrete blueprints and building blocks that in the end materialize into software assets that people can use. We've seen this slide before by Ed had something on this. So there's these building blocks that separate into organizational and business building blocks and technical ones. The whole explanation of this is on the DSSC website, but as I said, they provide guidelines, specifications, common standards, and so on and so forth, how to actually set up data spaces, how to create this interoperability. And I will guide you through some of these real quick right now. So on the organizational side, there are these three blocks like business, governance, and legal. And in other words, the business building block is about providing guidelines and templates how to take business decisions in this context. The governance building blocks is about participant management, how to on and offboard participants, how to do all this stuff. And the legal area is about like regulatory compliances, and contractual frameworks on participants and between all these transactions. Now, maybe for some of us, the more interesting part is the technical area that is separated into these three parts, namely data interoperability, data sovereignty and trust, and the value creation enablers. And in the data interoperability part, this is a very important topic to me is the term of vocabulary hubs, which we also had in earlier discussions, and approaches for provenance and traceability. In the sovereignty part, there is a very strong, or it's very important to use the web standards such as the verifiable credentials or the open digital right languages to properly define and specify things. For Value creation enablers, we heard the term DCAT many times today already, and there's also a more specific specification on value-added services in the DSSC. And these building blocks basically materialize into concrete implementations and software assets that participants in data spaces can use. So on the one side, there is the so-called participant agent, or in other contexts, this is called a data space connector, so a piece of software that you can run. And there are shared services, which are not really centralized, but somewhat centralized, that all the participants can use. And I would like to go into detail into two of these. One is the connector, and one is the catalog, or more precisely, the vocabulary hub. So this data space connector is a piece of software that every participant runs, and that enables them to use the data space features. So we have two planes, two layers. The upper layer is the control plane. Can I use this? Yeah. So we have two instances of this connector software running, so at a data provider and a data consumer. And this connector enables them to use all these data space features, such as identity providers, contract offerings, contract negotiations, policies, monitoring of all these things. And then the lower layer enables actual data exchange. There's one example implementation in the Gaia-X landscape. That is the Eclipse data space components, in short EDC. And there is a trust framework extension to this, which basically materializes all the Gaia-X requirements into usable software. And for the data space protocol, which is basically this figure here, there is a formal standardization going on, driven by the IDSA and by the DSSC, to push this into a ISO AEC norm. In Gaia-X, we use this protocol as follows. So there are credentials, or AKA self-descriptions, that describe things such as data, participants, services, and so on and so forth. And they are available in as some form of documentation. There's a formal ontology for this. There are validation shapes for this. There are examples, and there is tool support to also enable this to maybe non-tech users. And the core idea is to create some self-description about stuff and then send it to someone else who can then, human and machine readable, understand things. And there is an extension to this. You can add this trust. So you do not just claim something, but you let it be confirmed by a third party, and then you can give it to others so that they can more believe in what you stated. Okay, now we have all these all these blocks, and now there's still this gap of a common language. Like, what do we put into these self-descriptions? So in the international data spaces, there is the international IDS information model. There's an RDF OWL ontology to describe things in a data space. Just to name a few, there is participant management. There's content and data management, also based on DCAT and so on, DataCube and so on. There's contextual information, time, space, and so on and so forth. And there's provenance, policies, data usage policies, and so on and so forth. And addressing the brief introduction that Sander gave before this afternoon session, we in the IDS address this topic of what's a common core, how do we apply this to different domains as follows. So we have the IDS information model as a common core, and whenever you build an application with this, or you build a domain data space, or just an application within some data space, you use all the parts from the common core, which are mandatory and the ones you need, and then you extend this with the help of application profiles with your domain-specific vocabulary and language, and plug this together to communicate in your domain context. Now, coming back to this overview, I just highlighted the data space connector, and I would now like to speak briefly about the vocabulary hub as a very important part of this shared services area. And the definition from the IDS on the vocabulary hub is that it provides some tools and functions to create, improve, and publish terms. And I just see that this figure is a bit small, but I will guide you through it real quick. This is very similar to the data space protocol we've seen before. So we have some data provider, and we have some data consumer, and then we have all these data space features and building blocks in between. And now we have this addition, a so-called vocabulary provider or vocabulary hub, whatever you would like to call it. And anytime a data provider adds data with metadata to a data space, they also push the vocabularies they used to this vocabulary provider. So whenever someone, as a consumer, reuser, or any other role, wants to search for things, they can pull the used vocabularies from this vocabulary provider and then use this language, these terms, to formulate queries and find things, because they were defined using these vocabularies, so you can then, after that, find data, services, and so on, using the same language. This is also included in the, or this was also done in Gaia X, more concretely in the, in the XFSC federated catalog. So this catalog has some vocabulary hub features. I put some links here on the slide, and there's a structure diagram on the right. The catalog has many components, and so there's client software and a portal, like a web interface that people can use, and there are other components. One catalog might have intersections with other catalogs and communicate with other catalogs, and here on the bottom left there is this schema management component that can communicate with external schema repositories, which, as per this definition, can be in a vocabulary hub. So in this XFSC federated catalog, in the Eclipse Gaia X context, you can use a vocabulary hub to define or to describe your data assets. And these were the highlights I wanted to dive into. And now just to summarize or conclude my talk. So data spaces are very important for data sovereignty, especially in the European Union, because this is a very prominent topic here in the European Union. The ongoing data space initiatives, so I just named a few, there are more here and there are even way more out there. They provide reference models, and they are growing in members and in impact. Then I highlighted the Data Space Support Center as some glue that puts together all these data spaces initiatives and aims to provide data space interoperability by providing blueprints and building blocks that are easy to reuse when someone wants to build their own data space. NTDSSC does not just provide documentations such as building blocks or blueprints, but they also provide hints to actual implementations. I highlighted two. So the connector software or the agent software and these shared services. Among one of these is the vocabulary hub. All these tools in the DSSC are based on semantic models. This is also a very good fit into today's workshop sessions in general. And now I would just like to also propose two opinions of mine on this scope. So given the goal that we would like to achieve data spaces interoperability, my first opinion or my first statement is that one of the most important things is that we have mutual understanding and common languages among machines and human and so on and so forth, and across domains, within domains, and so on. And in my point of view, one of the most important things to get there is provide vocabulary hubs, so a place to find common languages and to reuse languages, and semantic models that build a common core that you can then extend with your domain-specific stuff. And the second takeaway statement or opinion from my side is for data spaces, but also for interoperability solutions in general to get the impact and the reach we would like them to have. It it might not be sufficient to just produce documentations and standards, but especially to reach the broad audience of such tools. It is very important to also provide tool support to lower the entrance barrier to the accessibility to these tools. I mean, not just any tools, but please use web standards, W3C standards, we heard DCAT so many times, and so on, as much as possible to make tools, also the tools, as reusable as possible. And this is the end of my talk. I thank you very much for your attention.
Great. Yes. Can we go to the Slido with the two statements so people can get their votes going, and we can see how we're doing. In the meanwhile, maybe we can also do, because we are quite doing good on time, so we can definitely have maybe a few questions. And I see Peter is already. Of course.
Thanks. I think vocabulary hubs are a really interesting idea, and I'm mainly triggered by the plural vocabulary hubs. Like, isn't that going to be a problem if there are multiple?
Very good question, thank you. Why is there a plural like this S, not vocabulary hub, but vocabulary hubs? This comes from one of the core aspects of data spaces, because data spaces are distributed systems, so everything should be distributed. This also holds for the shared services. So as per design, there should not be one central catalog, one central vocabulary hub, one central identity provider, and so on. So the data space initiatives such as GaiaX, IDS, and so on, they define how it could be, and then, but they do not operate the data space themselves. Which is why in terms, there might be more than one catalog, might be more than one vocabulary hub, and so on. But of course, usually, as far as what I observed in the data spaces, you have one very big catalog or one big vocabulary hub that either queries the data from the others, and so on and so forth. As we've seen with the open data portals, right, you have some hierarchy there. But as per definition, we have a plural there, and there might also be like non-public things in data spaces, because you might have your private vocabulary hub, for example.
Right. And towards the vocabulary hub, do you already have examples of do you already have good examples of, hey, in that member state, there's already a very good vocabulary hub, or in that data space, there's already a very good example of a vocabulary hub, or is it still a pretty undefined term?
For a country or national based, I can't give a statement, but for domain data spaces, they rather quickly agree on some core vocabularies that everyone wants to reuse. And then, as we've seen in Ed's presentation, there's this long tail, and there's many vocabularies that are very niche ones, right? But you usually have a few core vocabularies that everyone agrees upon, and then lots of other stuffs. But this is true for these domain data spaces, because people from one specific domain, they rather fastly or quickly agree on each other, as compared to domain agnostic initiatives, of course. Yeah.
All right, maybe we can do another question, and in the meanwhile, we can also move to the next statement on Slido, so you can multitask and ask a question, answer one and ask one in the same round. Anyone else? Yes, Georgia.
Thank you. The role of DCAT is not very clear to me, because I heard that someone wants to use DCAT also to, do some extension for health, for mobility or something like that, but DCAT doesn't do that. I mean, it's really not for going into the detail, the content detail of that. And you mentioned about product and services, so I just want understand a little bit the role of DCAT in that.
Yeah, I totally get your question. Yeah, thank you. So DCAT, okay, this is a vocabulary for data catalogs. So the vocabulary does not do anything, sure. I referenced the DCAT application profiles. So there are application profiles, like every data set should have one title and so on and so forth. And what you can do is you can use one of the DCAT application profiles out there, and then you fine-tune it to match to your application area. So you could either use the existing constraints and make them more narrow, or you add domain-specific details at the end of this shape. Like every data set from mobility should have a geolocation in it, for example. And this, by doing so, you can use this common core, like use the DCAT vocabulary and the other vocabularies, but in this shackle shape or in this application profile, you can add your domain-specific details to it, which can then be used to form a data model in your data space, but also can be used for validation of such data, which you then use this metadata. Does this make sense?
Yeah,
Kind of.
No, but I mean, I believe that the initial requirements of DIGA should be taken into account when we do this stuff, you know. And that's why I think that it was really mentioned that they don't enter into the detail of and the content of the data sets. It was meant like that, so that's why it's like it's no longer its nature, you know, but we are just adding things that is probably not DCAT anymore. It's more going inside. That's my point. But yeah, I understand your point. Yeah, definitely. DCAT is also well known and used, so yeah, I understand.
Maybe it would be better to say use application profiles.
Yeah, yeah.
And in the application profiles, if you have data sets, then you might want to use the DCAT vocabulary.
Yeah, got it. Yeah.
Okay, thank you.
Yeah, I have to constrain myself in but I think we can move to the next presentation where Claudia will talk about the UX side of getting people into how do we get people working with these schemas and what and I'm sorry, yes, indeed you have your colleague Matteo with you.
We're going to be two, yeah, today. I will see this here. Okay. So, hi everybody. I'm Claudia Pollina. I'm actually a service designer, so I used to design services, so I'm kind of new in this field. I was introduced to Semantic field from Georgia or Roberto Polli and also Matteo at least 2 years ago. And let's say that this, I will say this new point of view, this fresh point of view from a designer might help in the understanding of how we are going to adopt Semantic. I'm really interested in this part. So today we are going to talk about the adoption, so fostering semantic interoperability adoption. Especially, we are going to talk about the Italian case study on semantic interoperability, so what is going on in Italy. And our goal is to increase the adoption of semantic assets within the Italian public administration and beyond. So not just public administration, but also everybody that exchange data. We are going to talk especially about two contents, about achieving adoption with a design approach. And Matteo will introduce you to some studies we are doing on semantic APIs to make data exchange more understandable. So what is happening nowadays in Italy is that we are funded by the Next Generation EU, and we have the two different platforms. We have this National Digital Data Platform that is a platform of exchange of data between public administration. And we have also the National Data Catalog, Schema-Govit, so the catalog that we are going to talk today. So we have a wider strategy of interoperability, and we are going to, so what we want is to make exchange data and information interoperable, implement the one solely principle, and most of all, design and enable public services for citizens, because what we're doing here actually is like improve the interoperability of services for citizens, but also for the people that work in the public administration, so public sector operators and citizens. So what we are doing is maximize, what we want to do is maximize the value of public sector information and data through interoperability, with this exchange of data, but also with a set of tools, platforms, portals that we have in Italy. The main one, as I was saying previously, is the Italian Interoperability Platform, the National Digital Data Platform, the Open Data Catalog, and also Developers Italia, that is the main reference for public administration software. Open source, where you can find actually what is the interoperability ecosystem. And of course, as we are going to talk about today, Schema-Govit. Schema-Govit is a catalog where you can find semantic assets, so resources. We have vocabularies, ontologies, and data schemas. So here now actually is helping what? To make the semantic assets more available, to foster also the development of semantically and syntactically interoperable APIs, so serves both public and private sector entities that want to, which exchange data with the platform I was saying before, so the interoperability platform. And the goal is, of course, to ensure that the format and the meaning of the exchange information are preserved and understood during the exchange. Here you are talking why we are doing this. Here we are presenting, let's say, a case study of a national level case study. The milestone, let's say that back in 2017, Georgia and AGI, that is the Italian agency for digital transformation, just for digital, yeah, there was a repository, so a GitHub repository. In December 2021, we started with an MVP phase. Within 3 months, we developed this catalog, this MVP catalog. And we work at Agid and with Georgia also from CNR and the Department of Digital Transformation. We had more or less 80 resources at that time. Now we have more or less 200 resources, and our goals are to increase the numbers of resources, so engage more public entities, and on the other hand, consolidate the infrastructure, so infrastructure consolidation. Nowadays, we are working to a new functional architecture, new functionalities, new tools for contributors, and we are also improving user experience. We are not doing it this alone. The implementing entity is the ISTAT, the Institute of Statistics of Italy. As I was saying, we have more or less 200 semantic resources and 19 contributors. Let's say that in Italy we have more or less 40, public, big public administrations, central administration. So we are now working to engage the other 50% of contributors. In Italy we have actually almost 22,000 of public administration, but the bigger one, the one that have high value data set are more or less 40. The value proposition for users. So what I'm going to talk today is a design point of view. So user engagement, as Georgia was saying this morning, is really important for us. So understand which is the value proposition for each kind of users, and for us are contributors, so public administration that contribute to the catalog, the users, so the public administration or the private sector entities that wants to reuse assets to develop application and digital public services, or for instance, research institution, researcher that need the semantic assets to support their scientific research. And as Matteo will talk later, also developers, technicians that work in-house or in-house the public administration or as suppliers, and who needs to develop and manage the life cycle of e-services, of APIs. What we are doing for them is support data standardization, facilitate the development of new information system, ensure that the semantics are available and searchable. So how does it work if you are developing an API? So from the developer point of view, you go to the catalog, browse, filter, and navigate the semantic assets. You identify the resources. You implement your own API. And expand, let's say, the public administration, or ask to expand the semantic when necessary. Verify your API. So we are developing some checkers that help the developers check if their APIs are aligned to rules, let's say. So, and then you should publish your API in the platform of exchange. Now, if I should say it correctly, none of the APIs in the platform now have the semantic, but we are working on that. The catalog is a federated system of semantic resources that are published by contributing entities in public repositories, and they are gathered through an harvesting process, as a lot of others catalogs do, actually. So what they should do is to model and publish semantic resources in these public repositories following guidelines. In Italy, let's say that public entities generally doesn't have a lot of level, have a low level of semantic expertise, giusto Giorgia? Therefore, actually, we provide support services, and I have seen in a lot of different presentations that the support is really important to assist this administration in the modeling and in the publishing with our semantic experts that handling the resource modeling and the publish. So how it works if you want to contribute? You should analyze the resource that needs to be created, modified, identify the contribution model, let's say if you want to be helped by somebody, or if you have your own expertise by your own, or if you have a supplier that can help you to do that. We used to organize a contact or a kickoff meeting to engage with the stakeholder, and we try to understand if the guidelines were followed or if there are some problems in the modeling. And then we harvest previously in test, and then we publish in the resources. Once the harvesting is done, actually contributors can continuously expand their set of semantic resources that they have in their own repositories. How we did that, and then I will pass to Matteo. We used a design approach. So we have this platform called Designers Italia, where we theorized the design approach point of view to like design tools. So we understand the context, design, build, test, and plan, of course. And our principles are transparency, privacy, mobile first, open source. And our approach is systemic, user-centered, co-design, and iterative. So when we did that, we identified our stakeholders and how the system should work. So we mapped our stakeholder in an actor map, and we designed the system. We identified the user scenarios based on user needs. We tried to understand which were the main epics and the user stories to build the service, to build the catalog. We designed the interface and information architecture of the catalog. And we are doing it nowadays because we are redesigning again after 2 years the catalog. And we like to make it iterative and collaborative. So we performed qualitative research, or we bring people together to collaborative sessions, or we asked user to perform usability tests to assess what we actually have done. What we are going to do next, we are going we are now published a new guide, the new guidelines, and we are going to test with some users, and so we do somehow a public confirmation of what we have wrote is understandable, and we are going to go on the user engagement.
Yeah, thank you. Now I'm presenting a project we are doing to join the API world and the semantic APIs and the semantic world in a way. We have this catalog, we have interoperability guidelines that are laws in Italy, and we are with the interoperability guidelines, we have achieved the technical interoperability. We want to achieve, we'd like to achieve semantic interoperability too. So we want to reuse the semantic resources published in the catalog to allow the development of APIs that are both semantically and syntactically interoperable. And so we want, when we publish an API, we want it to be aligned with the domain semantics that exist, and data should be transformable between in a consistent way between the API payload and its semantic counterpart. So our proposal is insert syntax, insert extensions to the OpenAPI specification in order to express the semantic meaning of the data and allow this kind of transfer of conversion. What we would like to do is make these two words talk in some way. Because, of course, API developers should usually think about what they exchange, and semantic people are using a very high concept, and they usually don't talk too much, and it's very hard to explain them. So explain these things also to developers when we talk to them. So we want, and it's written also in some guidelines, that you want to use the existing concepts and control vocabularies, or expand them if it's needed. So if you don't find something, you need to expand it. And as I said, you want to exchange data and being able to consistently transform data to its linked data counterpart. Of course, the JSON LD has been chosen as the natural semantic extension to the JSON format, because it's the JSON contains the JSON specification, so it's an extension. It adds context to the JSON data. It adds object types, and it adds objects ID to identify enable dataset interoperability between datasets. As a comparison, you can see API-wise, you have a JSON which is simple, terse, efficient. This kind of JSON is only 146 bytes. Its JSON LD counterpart can be almost 5 times bigger, And of course, when you talk about APIs and data transfer, data exchange, you want it to be cheap in energy-wise or whatever you want to say. But they have the same information content, and for APIs, we want to maximize the variable parts over the context, and the corresponding JSON LD adds just some constant parts. So what we want for development, you can either start from a JSON LD expression of your data and then convert it to a JSON, remove the constant part and the useless nesting in useless. Let's say I say useless and not needed for that exchange, and or otherwise you can start from an existing JSON if you have the JSON in your APIs and then map it the other way. So for JSON to JSON LD conversion, of course, you want to restructure the JSON data so you have a proper nesting as defined in the ontology. You want to define a context. You want to map the JSON elements to the corresponding concept in the ontology. You want to define the types and the IDs. And I stress the IDs are important because the main objections that we have is that this is just another very detailed way of documenting the API data structure. But if you add an ID and the ID is stable and it's an IRI, you have the interoperability between different data sets and different APIs. So this is it's another level of interoperability that you want, because if you just say my name data, my name attribute is connected to the name attribute in the ontology, you're giving a very thorough explanation of your attribute, but you are in a way you're documenting the attribute in a strong way. If you add the IDs, you are going to make the data interoperable. So what we propose is a semantic extension to the OpenAPI specification, adding for now 2 different fields. One is an XJSON LD context, which can be added to any object in the schema and can be nested, of course. And in the context, you link each field of the JSON to its corresponding attribute in the ontology, or you can use it to expand the control vocabulary, which is connected to the data. And the XJSON LD type allows to add a type to an object, so you have both the connections. We are still looking into a way of expressing in a clear way the ID. These 2 extensions are compatible with the OpenAPI specification, so it's not. It can be part of the specification of the API without any added data. As an example, here is a schema. We added the JSON LD type and the JSON LD context. This is from a schema that is already published on the schema.gov.it website portal that Claudia was showing before. And we have an experimental Swagger editor that is able to understand this kind of extension and tell you if you are using the ontology in the correct way, and if you are connecting every attribute to a corresponding ontology. So this editor is going to assist the developers and show if they are connected. Okay, these were the statements. So
these were going to be the statement that you're going to see later. So summarizing, let's say that what we want to do is to engage. No, these are going to be the so if you want to stress them, but to launch them, you can do. But what we want to do is to engage public entities, going beyond just law enforcement, but with moral suasion, and with what we are going to do is to really improve public services. And then on the other hand, we need the developers to be engaged on that, because they are do it. So it's really about developer experience and how do they do their own work. That's it.
Thank you very much. Let's quickly hop over to the Slido statements while we can also do a few quick questions because excellent.
So you declare as a goal achieving interoperability between public administrations. So how do you track that this year interoperability is higher than 1 year ago?
Okay. Can I use this? We are working on that, but I think we are going to have two ways. First of all, how much resources we have, so publish, and then we would like to introduce in the onboarding of the national digital platform, where the exchange happen, an input where you can put the schema, so we can find if that API has the schema, how many times this was used. We are working on that. We don't have it ready, but on the other hand, we don't have it also too many resources so far. So, but we can do in these two ways. Yeah.
Thank you. Maybe while we hop over to the next statement on Slido, I just want to have a quick peek around if somebody else has. Matthias?
So if we have two existing agencies that have the same kind of data, they have already built their APIs, they are different. And now they want to be interoperable. They could provide two different contexts that says, oh, interpret this field in this way, and the other one says, interpret this field in this way. And then they will actually achieve interoperability by using the JSON LD context to match things. That could be one option. Is that one of the scenarios? I'm asking about the scenarios, basically. How, in practice, is that, no, we can't rely on the RDF and the context. We should instead rely on like JSON schemas, this more syntactic format, or should you do on the interoperability on the RDF level, or do you foresee even more?
Yes. Yeah. What we were thinking is, as you said, the two agencies look into the schemas, the schema.gov.it. They find that there's an ontology. They map their data in the same way, and so they can the same concepts are mapped to the right with the context. And another level is they give the right ID to their, like if I have an ID for person in some defined in the registry for people, and I have any other information about let's say income for people, if I use the same ID, I can make the data set interoperable because the graphs are going to join because I know that I'm talking about the same exact object and not just someone that has the same name or the same attributes. So this could be the other level. But at first, I map the concepts to the right.
Because another scenario is that they use different vocabularies, but they should be similar, maybe different categories or something, and they need to align these categories, and then they need to change their APIs and their internal representation, and there's a lot of effort. That
could be the long way, but the fact that we want to adhere to a single catalog is we want eventually to have a single point of a single source of semantics. Of course, it could be an ongoing process in order to, if you start from different vocabularies, you need to, in some way, to jump. But the catalog helps you understand that there are different vocabularies that you need to.
So the main scenario is more to help people when they do in the next version of the API to be more aligned.
Yeah.
Yeah, that's what we are facing so far.
Okay, thank you.
All right, thank you so much, Claudia and Matteo. Finally, we managed to have Italy here. Last year, I invited them, but it wasn't possible. And now, to close this workshop, as I said at the beginning, I invited the speaker to lift the spirits of everybody because he, over 30 years of trials and errors, and managed to reach interoperability at a massive scale. Okay, so what I ask him is to give us a little bit of history, a little bit of perspective, and whether we have hopes or not. So here is to you is Stefan Hoppe.
Thank you so much. I take that microphone because I'm walking always. So that gentleman on the picture is really me. I just decided to let my hair grow, and I'm in a little bit challenge with my kids, which are over 20 years. And my message is because I can. Okay. Yeah, my talk will be a little bit different to what you have listened till now. But I want to give you an overview of an industry-driven initiative which is heavily relying on interoperability, semantic interoperability. And everything what is coming now is just and only in the focus of industrial automation. So when I say we are the home of semantic industrial interoperability, it doesn't mean we own the world. It is in our small bubble, okay? So let's start. So the organization which I'm representing as a president and executive director is the OPC Foundation. And that's what I believe the world's largest ecosystem for cross-vendor, cross-domain industrial interoperability, semantic interoperability. And the technology, what we offer, is called OPCUA. It's a unified architecture. And that's exactly the promise of secure, reliable semantic interoperability. To give you just one slide, I'm staying here in front. To give you just one slide, about the organization. The OPC Foundation, the headquarter, by the way, is US-based. It's in Phoenix, Arizona. But honestly, I believe, even I'm the president, I believe we have 1.5 full employees on our payroll, and everybody else is industry donated members, people from the industry. And I can also share some details. Just yesterday, I received the message we are now over 1,000 members. And to give you an idea, the yearly revenue is about $4.5 million US, what we are collecting just by member fees. And if you believe that's a lot, compared to other associations, that's very low. For the highest member fee category for the Siemens, the Microsoft, the Googles, is $18,000 US, which is peanuts for them. But honestly, I want to keep these member fees low because I do not want to just have a big team of stuff and then everybody's just doing something to do something. We want to just fulfill industry needs, and therefore we need industry people. And if they are not convinced, then it doesn't make any sense for me. So what is our vision? Exactly in this range, we want to provide a secure, reliable interoperability, which is independent from any vendor, any platform. Platform means, in our meaning, implementation language, domain agnostic, which is scaling from small sensors up to the cloud and data spaces. And you will see that from my vision, the OPCUA technology is bubbling up into becoming the infrastructure for a data space. Because till now I have not figured out what's missing. Oh, by the way, from which Fraunhofer are you? Fit in? Okay, I was in Dortmund with Fraunhofer. Okay, When I say secure, reliable, this is for me the highest priority. If it's not secure, it has no value. Also, semantic interoperability has no value if it's not secure. So this is what we have to keep in mind. OPC Foundation is non-profit. The UA stuff is an IC specification, and everything which is available is open. The O from OPC Foundation stands for openness. So all specifications, once released, are public available without any fee. We have tools, open source, sample code on GitHub, free of charge for everybody. Certification, we opened our labs even for people who are using third-party toolkits or the open source. They have to pay the engineer doing the job, the certification, but we as a foundation earn, I think I put a $50 bucks on top for the sending out certification and so on. We are not earning money with certification. Why should we? It is delivered by the industry from their money, so we shouldn't earn money with that. So it's pretty open. We have an ecosystem with toolkits and education, but what I'm really proud on is the super modern IPR policy. I'm an electrical engineer. I every 2 weeks I have a legal call, and after that I need a bottle of wine. Okay, so it's not my favorite topic, but what I learned is if you do not have a really good IPR policy, that's a blocking mechanism for good technology. So just having good technology is not enough. Just being a researcher and have a fantastic idea is not enough. And so what we have is, interestingly, that all members agreed to not sue any member, but also they agreed to not sue anybody who is implementing or adapting it. So members are protecting users. And if I tell you who is our member, it is the who is who of the industrial automation market, the Siemens, the ABB, the Amazon, and so on. So the top 50 companies with the top 50 worldwide revenue are members of the OPC Foundation. But it's not only OT companies, it's also IT companies. Alibaba Cloud, IBM, Google, Microsoft, Amazon Web Service, SAP are all members of the OPC Foundation. For me, this is one of the very significant difference to all the other associations where you always have the closed club of we are the robot companies or we are the cloud vendors, and they talk to each other. And really interesting is if people from different skills come together to learn from each other. That's why I'm really proud to get invited here today. From the 1,000 members, around about 60% are from European companies. So now a little bit about the technology, and I have to try to not talk too long, but in a little bit high-level introduction into the world of industrial automation. In industrial automation, people are not talking to each other. For you, it looks like it is one big blob, one market, industrial automation, but inside that bubble, you have factory people, and factory people are not talking to process people. Even inside companies, they are completely separated and they are bound together on vice president level. And then IT people inside that automation world are not talking to the OT people, to the operation technology people. And there's a reason, because the OT people are normally running the real machine, the robot, with deterministic real time, where you have to calculate specific routines every 50 microseconds. And nothing in the world should interrupt that 50 microseconds. Otherwise, the robot cannot move precisely. And so the OT people have totally panic on the IT people grabbing data, collecting data, because they are disturbing that 50 microsecond cycle. I do not know when they are reading it and occupying the CPU. So OT and IT people are not always the best friends, okay? But in the earlier days, when I started 30 years ago, it was always two people met, and then what protocols are you supporting, what protocols are I supporting? Oh, there is one, okay, great, and now let's talk about the meaning of the data. So it was an individual contract between two people, and obviously these solutions are not scaling. So what we want and what we do and where we are extremely successfully with OPCUA is we want to have this network of information, and I believe that protocols are less relevant. we have to agree on the meaning of data, on the semantic, and I don't have to convince you, you are the semantic experts, right? Okay, so my message here is OPCUA is not a protocol, even a lot of people believe that. It is a framework where you first of all design information, you model information, and once you have done that, and this is where we are a little bit ahead, I believe, because also transport and security is already integrated. What we do is we are collaborating a lot with other associations where we explain them how to exchange in a secure way semantic information, but the others are writing the semantic for specific domains. And this is what I'm talking a little bit about. I'm speeding up a little bit. So OPCUA is a super rich modeling language, but it has transport already included. You don't see that, it's in the framework, and it's addressing different transport mechanisms because you do not have the one simple mechanism how to exchange information. Again, the field bus people, the robot people, as a synonym, they need a field bus to be able to share super large information in a 50 microsecond cyclically. And they are getting rid all of the metadata. And that's okay. But if you bubble up more to the SAPs and data spaces, then you have many more data, many more meta information, but obviously you are not talking about 50 microseconds. So we have a one-to-one communication client-server, but we also have a pub-sub mechanism, one-to-many, like I do here right now, but also many-to-one. Many machines push data into one data space, okay? And so what we have is exactly that first you define your semantic, and then these transport mechanisms over different protocols, TCP, UDP, MQTT, are available, but also REST interfaces and file transfer. Overall, we have security built in by design. It is not only for the transport layer, it is also for accessing information, who is allowed to browse, see, read, write, whatever information. All this is extendable for sure. It is scalable, it is between machines horizontally, but machines can talk to IT services in data spaces. You can also exchange information between digital twins and from the cloud IT back to the machines, obviously. I spoke about the internationalization already. It's an IC spec. It's local standards in a lot of regions, China and so on. And it's independent. There's nobody who can influence the OPC Foundation, not one big vendor or who else. Okay. OPC, and that's also one really critical important message, has been standardized within just 3 years. 3 years only, 2003 to 2006. I had the pleasure, I was not designing the standard, but I made the world's first OPCUA product in the year 2007 in an embedded PLC. But what's critical important is the basic standard has never changed. So we have backward compatibility for 18 years. This is what industry is looking for. All these standards which are changing every 2, 3, 4, 5 years, or the IT companies, and I shouldn't do that because it's transported, but I'm connected to a couple of operating system companies from North America, and they are changing things whenever a new product manager is coming to be shiny on his own. They do not have long-term commitment to industry. That makes it difficult for industry. Okay, just a picture here, because the OPC spec is in multiple parts, 23, and if you believe that's too complicated, well, then you are one of these people who tell outside, oh, we make everything easier, because you believe the world is easy, and then you make documents for with 1, 2, 3 specs, but you did not figure out, oh, you need secure onboarding and discovery and this and this and this. And if you have a full picture, you need a more modular specification. For me, OPCUA is something like a big Lego brick system, and then you can select what makes sense for you. So even there are a lot of Lego bricks, it doesn't mean that you have always to implement everything. For example, if you have a controller who is controlling the robot, normally on this level you do not implement REST interfaces. That's more IT approach. And the opposite, obviously, a TCP or UDP connection in a data space doesn't make any sense in the cloud. So you can scale functionalities, and that makes it manageable. I mentioned security already, and I just want to touch it. Security is the most important topic. Again, if you are not secure, then all the other funny features have no value. So we implemented OPCA with security by design. Again, it's not only by transport level, also who is able to access and read and write what kind of data. But we also provide our own central and decentral certificate management. You are not going with memory sticks in a production line and update 5,000 devices, right? This has to be highly automated. And obviously, we are not doing something on our own. We are using existing security standards from the market. We are not redefining the wheel. But having this in a spec is not enough. What you need is you need a team which you need a continuous monitoring of this. So we have teams, security experts from Siemens, ABB, Microsoft, AWS, and so on. They meet weekly to act in a reactive way, something happened, or proactive way. That's really important. By the way, a little bit of our income money from our member fees we are donating to hacker events where industrial hackers try to break into systems. Till now, they have not been able to do it if the device was correctly configured. And what we do is a little bit education. Even I have not read all the specifications. Why should I? There's a one-page summary for people who have to do the configuration of security. So everything is shrink down to one page for users. This is what you need to do. And we are really proud that we have been reviewed twice, meanwhile, by the German security government because of the relevance for the German industry, but also, meanwhile, by the France government, ANSI. And also the US FBI and Homeland Security have made a presentation 2 weeks ago on our virtual event. So because of the relevance in critical infrastructure, right? Okay, so overall, as a short summary, again, OPCA is a super rich modeling language. It provides also inheritance, and only the person from Fraunhofer knows what I'm touching here with new approaches in Germany on asset shells and so on. And there's flexible transport included in security. And this is now makes OPCA available in different levels. In the level 1 I was talking about in the factory floor, right? But also from the factory floor, number 2, pushing data up into cloud systems, and also number 3, in data spaces, asset shells or digital twins, whatever. And I'm talking a little bit on every level here. On the factory floor, if you go to a factory, you have machines from different suppliers. You have a robot, and the robot is running one ecosystem with Profinet, and you have another machine running a different field bus system, and these machines cannot talk to each other. That's fact. And so we started an initiative, and the who is who of all industrial automation vendors is here, is committed. And to shorten the story, now everybody can talk to everybody else in real time, deterministic, in the factory. So that has never happened before. We are really proud on that. We closed the gap that machines from different suppliers can directly, horizontally talk to each other. Talking about number 2, how to move data from the OT world to the IT world. And here I have to say this blow my mind, because I'm a field bus person. I started 30 years ago on this field bus level with a robot. I have never thought that this idea of interoperability, semantic interoperability, would bubble up into the cloud, and we would, with the technology, would bubble up. But a lot of people mention that MQTT is the de facto standard to move data up, but that's not enough, because MQTT is not giving you any payload. So we put OPCA description of our messages on top of MQTT with different encodings and so on. And right now, it is supported by Alibaba Cloud, AWS, and Microsoft already. And the others will follow. And so then you have this pull and push effect if cloud vendors jump on this, because for them it's a USB connector to get data, then the controller companies jump on this. So you have the who is who of industrial automation, Beckhoff, KUKA, Phoenix, Siemens and others who are supporting out of the device this standard. For digital twins, it's easy. If you have a real robot following the semantic information model, I'm a robot, and I'm talking about information modeling in the domains in a second, then we can just instantiate another instance in the edge or in the cloud. We do OPCA over MQTT communication to move data from the physical device to the digital representative. And that's also available as open source. We cooperated here with Digital Twin Consortium. And same is happening now. I'm shortened this here because I believe this has no relevance in Belgium and DOE because it's German specific with the asset shell. I'm not, I have my doubts, but okay. What's definitely relevant, all the upcoming European regulations on digital product passport and like the first battery passport is becoming regulation in 2027. So people need to model data and access data and so on. And this is what we did. And it took us 3 hours to just do that. So there was another group defining the 100 parameters on a battery, and we just integrated that, made it happen. And so we have it on a secure international standard within 3 hours. What I'm really proud on that we initiated now a new cloud initiative supported by these small companies here, what you see. And on the right side, you see the goals. And again, I'm really blown off because whenever I dealt with these cloud suppliers, everybody says, we are the big Microsoft, we are the big AWS, and we don't care about your standard. We know how to store data in our cloud systems. So they have small satellites and then they collect data and they store it inside their systems how they want to store the data. But with this, they are destroying the context of the information models, what domain experts have done before. I'm a robot. I'm an injection molding machine. I'm a pump. I'm a motor. I'm an RFID reader, whatever. And all that information is destroyed. And now big end users make stress. Big end users say, we spend so much effort to write these information models. We want to keep that context also in the cloud system that we can consume the data later on to run artificial intelligence, machine learning. And interesting for me, AWS and Microsoft agreed. Microsoft is already doing that. They are delivering already, and AWS is implementing it right now in their Boston team. I have never thought that in my lifetime, even cloud suppliers would do that, honestly. And so if they do it, well, then we will create a protected identity, OPCA CX, that they are not just implementing a part what they like. So if they say, yes, I'm supporting OPCA CX for cloud exchange, then they need to implement the full package of features and so on. Only then they can say we are supporting this, right? You see that we have a lot of other groups which are on this cloud topics like REST interface, industrial metaverse is done, and also artificial intelligence, what we are starting now. So talking about information models, we are partnering with a lot of other partners, 60 or 70 partners in the world, and then we define this semantic information model for a specific domain, for the robot, for the pump, for the motor. And the result is always 2 parts, is a PDF for as a human readable, which is public in the web for everybody, and an XML-based stuff. I know, and it's on our roadmap to switch to JSON, but because of history being so long on the market today, it's XML. And also this is public available, searchable. So if you want to make the world better, then information obviously have to be free of charge available, that you avoid double standardization, that one team is not knowing that there is already a coffee machine, right? And the champions class of what we do is the harmonization of these over 150 information models. So whenever there is something coming which makes sense for others, it is documented, and all chairpersons of all these working groups are also in parallel in a harmonization group, and they make sure that we only have once a definition of the temperature and the robot and whatever. Okay. So you can't read that, but right now there are 151 information models available, everything free of charge, everything open. It is mostly manufacturing for sure, but we are heavily growing right now in the energy sector. So in the long list, what I saw here on interoperability, industrial automation is swapping over and growing into other areas. So there are a lot of energy information models from energy production, wind turbines, electrolyzers and so on, wind energy transport, energy measurement, energy consuming and so on. This is heavily growing right now inside the OPC Foundation. And what is also interesting for me, OPCA is growing out of the industrial core market, for example, into the medicine market, where you have the same situation that devices cannot talk to each other in labs and analytical devices. They agreed already, they have done this already, and you will see that robotics is coming more and more into the medical labs, where robots interact with machines to put in the COVID probes, open the door, put the probe in, get it out, and so on. So this will be much more highly automated. And last week, we started another group. So other groups are contacting us and say, hey, your technology is great. We want to do semantic interoperability in our market. The European Association for Vending and Snack Machines are now putting OPCA into that vending machines, not only for communicating from a vending machine to the IT world, but also inside vending machines, you have components from different suppliers. Okay, what else do we offer? We offer a complete OPCA stack free of charge as open source. Interesting, this open source stuff is also used by big automation companies like ABB, Microsoft, and SAP in their release products. And so they came together and they initiated, why should everybody else, everybody on its own implement a standard? Why don't we just donate one full-time developer and we make the world better and we donate it back to the world and we benefit also from that? Really fantastic. We have IoT starter kits. There's an academic program in 6 languages, free of charge for professors. We have a lot of success stories. That's what I'm really proud on. From the process industry, like the company Equinor, it's Norway's oil and gas company. They are producing around about 30%. Their new oil and gas platforms produce 30% of the complete Norway energy production. And all of that is driven with OPCA. They are pumping 1 million data points to Microsoft data clouds and data spaces and so on. Everything via OPCA. But it's also in discrete manufacturing at Renault, a lot in automotive. And the nicest story was published last week. OPCA is even in a rocket, in the Airbus civil rocket. So we are looking down to data spaces in the cloud, right? From the space, we are looking down. Okay, with that, last slide. OPCA, I believe it's a super rich modeling language. It's definitely the world's largest one in the space of AI, industrial automation. Because it has these 4 pillars, super rich modeling mechanisms, but a big ecosystem. Critical important is a really tool chain and adoption. Yes, there are toolkit vendors, and they have been the early winners of the race because they brought quality into the market. If you do not have toolkit vendors, from my point of view, you are nearly lost. Open source is great. I'm not against open source, but open source, normally the quality of open source is a little bit behind commercial toolkits, where they want to, they are investing, they are believing in something in a business model, they spend development resources, they get quicker quality, and so we are glad to have over 10 commercial modeling tools. And then I mentioned at the beginning, you also need a legal frame in the world. So it shouldn't be arrogant, but we feel, again, just inside industrial automation, a little bit like the United Nations, in the best way, in the best meaning. And I know we Europeans love it more than if I do this slide in North America. But it should say we are independent. There's not one company or one country who can dominate the OPC Foundation. A small company with a revenue of $10,000 per year has exactly the one vote as Siemens with a lot more revenue. It's one vote, and that makes us really strong. That have been my political incorrect statements. I don't know if they got integrated from back, but that was my overview presentation. Thank you.
Thank you so much. Yes, we have it. I tempered a little bit because there were 5 options, and I also put them in a statement, so we can put them up on from the Slido. And by the way, I want to really thank Nathan Gauthier. He's been sitting there and helping me so much in this interactive part of the workshop. So this would be the first statement. I think people are really tired of this time to even vote. But is this a poll? Because I don't see below the. Oh yeah. Now it's open. Now it's open for polls. Okay, so we can take questions for Stefan. And in the meantime, you can think of questions. I have to say, I mean, if I have a couple of key takeaways from you, is that if you do something that is really almost from the heart, with not necessarily the profit at the base of it, you can achieve amazing stuff. This is almost with no self-interest.
I tell you what I love mostly on my job is that, interestingly, the most time, 90%, I'm also dealing with super open-minded people who want to make the world better and so on, and that's so much inspiring. But yeah, sometimes you are in the middle of politics, then you have to try to escape the room quickly, or legal stuff is also something where, okay, good, but yeah.
Oh yeah, to know that Amazon and the other bigs and Siemens and Alibaba would agree on the intention, and because these are companies who are famously driven by profit.
Absolutely, and Alibaba just recently joined the OPC Foundation, and but also, for example, companies like Foxconn have been the world largest producer company, have been joined the OPC Foundation, and they follow, for example, also one of the companion specifications for robots. And I asked them, sorry, sir, why do you do this? Because you are Foxconn, you can do your Foxconn standard, right? With the Foxconn cloud. There's a Foxconn cloud. And he says, well, yes, we can do our own standard, but we want to grow with our Foxconn cloud, obviously, to the European Union and to US market. And then we have to support their standards. So that's why we are supporting standards. Here we go.
We can move to the second statement. And I had another question, more comments on the presentation. So yeah, but for those who, Sandra, you wanted? Yes, here's the microphone for you. Don't let me just be the.
Yeah, I'm quite curious because the technical part is often the easy discussion to have. Do you get a lot of back pressure of because in industries where you have critical infrastructure, I can imagine even just telemetry, or even whenever you network something that has been classically separated to the outside world, bringing it to the cloud, like just this idea, is it?
It is hard, but two things helped me, and this is what I learned when in 2014 the German BSI, the Office for Critical Infrastructure, contacted us. They made the proposal: are we allowed to analyze OPCUA? And at the beginning I thought, oh, I'm a developer, so I started 10 years developing, and I said, well, nothing is really secure, right? So whatever they find, we are dead. But then you make this kind of handshake agreement. Okay, they can analyze whatever they find. We have 5 months time to fix things, and then it's published to the world. And that's what we agreed on. And then I learned, if you have these kinds of reports outside, and if you open things, before we didn't have open source, the source code, the framework, the OPCA framework, was only available for paying members. We opened that. On the board of directors, we made the decision, and even I was not sure, do we sell all of our gold nuggets, give them away free of charge, and nobody's joining the OPC Foundation any longer. Interestingly, we gave off all golden nuggets, source code available for everybody, access to the certification lab available for everybody. You have to pay the lab person. We are growing like hell from membership, and we are attracting the world. I want to keep the member fee low, okay, but we are attracting the world, and only if you have open source, then people trust you. If you just say, believe me, here's the black box, you're lost.
Thank you.
So I don't see more hands up. Yeah, we can prepare for the last part of the workshop, which is a panel. We promise, despite whether there will be many things to say or left to say, that we will close this by 6, so that we set you free. Maybe we should put some of the chairs maybe here. Yes, and invite the speakers to sit and face the audience. Yeah, just the chairs.
Yeah. Connected.
I think it's how much are we? In principle, we're 6 or 7 people. Let's see. You know, everybody sits, and so we know whether there is less or more chairs. Okay. Yes, don't hide behind the table. So let's try and put this. All right. So what we can do is to go back, Nathan, go back to the results of the polls one by one from the beginning of today's workshop, and we would like to take either. So you can either ask questions related to that presentation if you remember the content, or if there is anybody from the audience who is disagreeing, let's say, with the statement, whether we would participate and have the speakers to whom the statements belong to come back with an answer. So the first one is implementing a scalable EU-wide system for creating and reusing semantic assets necessitates a unified process with governance and a collaborative methods, which is within a collaborative environment. This is clearly largely agreed as a statement, and this goes to Raf and Georgia and Evelyn. There is a 3% who said that doesn't really agree with it, and maybe 17% has been neutral. So is anybody in the audience that is in that 3%? 3%? Yes, very good, Matthias.
And this connects to one of the questions I had before, and also what Jorga said, that there is a span of people doing semantic assets, very complicated stuff, and some doing very simple stuff. They just have a web page or a PDF saying something about how their data looks like. And we need to be able to support both ends of it, both the very strong semantic specifications and those are very lightweight or something like that. And that means that we don't have to enforce this very heavyweight governance process on those that just want to tell a little bit about their data. I think that we should focus more on being able to tell the world about your specification and some of the specification will be very much more semantic advanced. So therefore, we cannot enforce the governance. We can offer it potentially. That's why I'm not saying that it's so important.
Very good. Any comment back from the speakers?
What we learned from the Marigraph project is that I think we need the governance. You have seen also the Italian case, you know, a kind of governance. I would say that is a lightweight governance with respect to digital Flanders stuff. So a kind of governance, I think, is there in any case. Okay, when you do modeling, also collaboration is there. I mean, it should be there. But I tend to agree with you on the fact that, as we said, that strong governance in our case doesn't work. Okay, I mean, really, public administration, they do whatever they want. So, like as you said, you know, that there is a difference, and so what we are saying is that probably we need the governance, but we also have to balance that, you know, in a certain way. So it's a kind of, yes, we need something, but not so probably strong as, so it's quite in the line of what you are saying, but probably some governance, I think it's required if you want to achieve some results at the national level, I would say.
Isn't it also a question of funding in each country, which maybe you don't have an agency that can take this responsibility and have the funding? So how do you do it then?
I mean, I can also leave the floor to Claudia. I mean, we noticed that schema.gov.it, for example, works because they are behind money from the recovery fund. So, and people are investing more in that, and then they are willing also to be, you know, inside the catalog. There are some actions also from APIs and all this kind of stuff, and money is a trigger definitely for public administration. I think it's also for your case in Digital Flanders.
I want to give a quick reaction also on the statement, because I also agree with the points you're mentioning, and I think in Flanders it's very interesting because we have indeed a strong governance for our vocabularies, application profiles, but then we have our implementation profiles, and those are very concrete towards a use case, and so not very reusable. Whereas you have the vocabularies, which are very much reusable. And we get a lot of, the interesting part is, so the strong governance is for the vocabularies and application profiles, but for the implementation models, those are not in our governance at this moment, but we are working towards also adapting those into our governance. And why are we doing this? Because we get a lot of questions from people who are implementing the standards. They want to communicate about their own implementation models, and they want a place to publish them. So they ask our help, they ask our support to do so. So this is why we also offer a governance, or we want to offer a governance for implementation models. And I think it's a very interesting point, but it's more as a means of communication and also, yeah, sharing the insights you have made.
Thank you. Your last point, I was thinking like we're making this discussion about strong governments, and it sounds bad, right? And I would propose take an economics view on this, in the sense that it's balancing costs versus value. But your last remark, the costs is also milded by a support. So there is less cost because next to the governance, you also have support. But on the value side, the other thing in Flanders is there's a high level of trust and a high level of quality. So there's a big value. So the engineering answer is it depends. So if you don't need that, so people will not be willing to pay the cost of a high, of a strong governance if there is no end result in value, or if there is a lack of support. I think that's the bottom line there.
Maybe a short reaction on the funding. So we have centralized funding for tooling, governance, support, training, but all the trajectories where we develop standards they are decentralized funded. So the party that takes the initiative funds the standards. And that way it's scalable. And on the other hand, you know that there's also a strong motivation because they're paying for it, they take the initiative. So that's the way we fund it in Flanders.
Thank you so much. Let's visit the second page from the first presentation. Thank you. Can we move to the second statement? Very good. So local, regional, national, and international catalogs are crucial for maximizing the sharing and reuse of semantic assets and should be integrated into the overall system. So yeah, this also largely agree between 20 and 70%. Sorry, altogether 70% agree, and there is a 7% disagree. Who's someone in the audience is among that 7%? Because this is, yeah, you?
I'm the 2%.
You strongly disagree. Oh, yeah, that was covered. Very good.
No, just to be challenging and the word catalogs. I find the pressure on catalogs. Well, luckily, like Peter was saying earlier about the vocabulary hubs, right? There's a multiple, so it's good that there is a plural, but the focus on catalogs often diminishes, I think, the self publishing or the own responsibility of making sure you have your shit together and you publish it on your own domain, right? I see catalogs, yes, as instrumental and helpful, but they're not core of the web and they're not essential. They're useful, they're helping us, but we're too much, in some cases, pampering people like, oh, we'll handle this for you, start doing it yourself. But I know I'm not honestly meaning that when I'm saying it. I just want to challenge.
Actually, I'm quite curious to get the idea of Johannes, because in data spaces, we don't have local, regional, national. Things tend to be domain organized. So I'm very interested in getting your idea on the statement.
Yeah, I'm very happy to comment on this. Thank you, Sana. So I was somewhere in the middle, like at 3 or 4, I guess, because I rather agreed to the first part of the statement, like, but not in terms of local, regional, and so on structure, but rather on some hierarchical structure. So this can be in a niche domain and then going to bigger domains, or in regional structures and then going to bigger regions. But this bottom-up approach of finding peers that agree on some common language, on some goals, on some common things, they get together and they exchange things. This is something I would like to push a lot. And like, but following this bottom-up approach, right? However, I rather disagree to the last part of this section, because the term of integration in this context was not too clear to me. Like copying data from a local catalog to a European catalog, does this make sense? It depends, right? Because often coming from this domain-specific idea, the local or the more domain-specific solutions, they have lots of metadata, lots of mutual ideas in there that might get lost once you get to a higher level of abstraction or higher level of representation. So it depends on how you put this integration, right? This is my point of view on this.
Thanks. Very good. Very good. Should we move to the next set of 2 statements that are from who was next in the it was Ed. Yes, Ed. Oh yeah, I should have understood it from the way the statement is formulated. Okay, this is a little bit more polarizing than the others, and that's what I asked for actually. So cross-border data spaces need a data coexistence approach. And we have, well, say 38% and 12% plus 38 is 50% on the agree side, and someone who's 35 unsure, and then we have a strongly disagree 12% altogether on the disagree end is 16%. Anybody in the audience who is between that, who's part of that 16%?
Maybe just one question to add to clarify this. So could this statement be translated to the fight of people that can't decide whether, so the one section of people that says we should map or integrate all data, like convert all data to linked data, and the other section is like leave the data at rest and just describe it. Is this the same, like is coexistence versus no coexistence?
You could formulate it like that, but I wouldn't just limit it to linked data. So basically, I would say there's, when people talk about data integration, is the assumption that the end goal is to integrate all your data. It's a reasonable question. So if your end goal is not to integrate all your data, well, what percentage of your data needs to be integrated? I don't know. Is it 10%? Is it 80%? Is it 60%? So I think what's the purpose here is to figure out if let's assume you agree to integrate 50% of your data. Well, what do you do with the other 50%? How do you just ignore it? Or do you try to say, well, actually, the purpose here is to integrate some of it to a high level, but also to provide services so that that data can coexist together. So that's not integrated fully, but that it can be accessed, it can still be used, the utility can still be leveraged. So it's trying to think about the data you don't integrate. What do you do with that? Just ignore, or do we need an approach about coexistence?
Yeah, so is integration a hard fact? Like, is it integrated yes or no? Or is there something in between? Like, it is integrated to some good enough manner and other data is integrated more sophisticatedly. This is also...
So
right?
Measurements of integration, yeah. Agreed, yeah. And we do a lot of work on that. Particularly linked data provides a nice way of looking at... So linked data is not integrated data. Semantically, it can be very loosely linked, very, very loosely, and barely even interoperable, we'll say. But that's actually a strength because you can start with very, very simple steps, and then you can have fully integrated, ontologies with everything aligned and fully operational. So that flexibility is very good. But outside of the linked data world, that doesn't exist as much.
Yeah. Anyone among the 11% who strongly disagrees?
It might have been a bit hard to read the question or to interpret it, but it seems to me that in the Fraunhofer presentation there was a lot of focus on the definition of data spaces in the European context, with on the one hand standards and on the other hand everything about policies, so that data can flow as people and goods are flowing in Europe right now. And by following standards, you create opportunities for serendipity, you reuse standards, and that makes the data flow and allows to be connected. And then in this presentation, I had the feeling that there was less focus on standards, and I had a feeling like, are we giving up on interoperability? And that was my motion to that I interpreted coexistence. Like it's there, but the standards is such a big effort. Let's drop it.
So perfect. You've fully got my presentation. So the philosophy here is if you have a standard in place and if people can port their data to it or make their data compatible with it at source or by default, fantastic. That's brilliant. But what percentage of our data will we actually be able to standardize? Well, and even I would even challenge the term standardization there, because I think we're using it for a lot of different things. Like if something is an RDF, is it standardized, or does it need to be with an agreed ontology that we're all using and have agreed to use? So what percentage do you think we can standardize?
Well, if you look at the way. So in Flanders, we're standardizing, and for us, it's a box of Lego bricks. So we reuse standards from WTC and Europe. And if you look, for instance, at the definition of a person in Flanders, then we are not integrating it with systems all over the world. I think integrating is a very weird way to look at interoperability, because it feels centralized. But by reusing existing standards, we know that 95% of all the data of a person in Flanders can be read by all European countries, and probably 85% by all countries all over the world that follow these basic standards. So you raise interoperability by reusing existing standards, and for me it's not about integrating integration, because it feels centralized, where we use semantic assets to create serendipity. If the world meets, most of the data will be able to flow.
Yeah, but like, so there's a couple of things there. Like, once you use a standard, if you agree to use a standard, that is centralization. It's a conceptual centralization. Like, if you look at, let's say you take, it depends on your goals. And what I was talking about is it's global scale. So it's not just for a region, but maybe the Italian example might be something a bit more, where you have lots of autonomy. And even, I was at a meeting 2 weeks ago with the European Commission, and they were talking about regulating schnapps. And is schnapps a vodka, or is it a different type of alcohol? I don't know. I like schnapps, but I don't know that much about it. But one part of the Commission says it's a vodka and it should be taxed this way, and another part of the Commission says no, it's not. It's a different type of alcohol. So the level of consensus you can get through a standard when you go to that detail becomes less and less. So from my point of view, it's not to say standards are bad. It's to say where standards don't exist, or more importantly, where centralization and the consensus of the meaning doesn't exist, well, what do? We still need to do something with that data to be able to use it.
Is it also allowed to make?
Yeah.
I love your statements, and I agree to them.
Yeah. No. But I want to give you. You're also right, but I want to give you one argument against why using existing standards and using existing data, and they can be mapped easily and so on, because there are. Don't kill me, please. There are a couple of people who earn money with just doing something new, even it's existing already. This was part of my statements, and now I'm a German citizen, and maybe right now we have the specific situation of that very specifically in Germany. But if you just take existing stuff, which can solve things, you do not get government money for research, and so. Is it recorded here, or are we public? So, for example, Fraunhofer. Let's say Fraunhofer from Germany, right? Mm-hmm. And he's a friendly, good person, and he's not what I'm talking about. But they have been involved in a lot of these, whatever, everything with an X in Germany. Gaia X, Catena X, what else X's do we have? Manufacturing X, Process X, Factory X, and nothing works together. Well, but I asked somebody else from Fraunhofer, hey, you have been participating always, right? They say, yeah, but we have to live and give some money, earn some money. It's but nobody wants to talk about that, and hopefully nobody's listened to this.
Well, to give you a brief insight on in just the way Belgium works. Yeah. So in Flanders we have 300 municipalities. Yeah. We have very big cities. Like Antwerp, where we have about 20,000 public servants, but we also have 1/3 of our smaller cities. They don't have that amount of citizens, and they all provide the same services to citizens. So services delivered by federal, regional, and local government. They provide about 1,200 services each, and they have a mix of 200 applications, not centralized, providing those services. If we would have chosen not to use standards and not to focus on interoperability, this would have been a disaster, because we wouldn't be able to provide those services. And I think if we talk about the challenges in Europe, where we want services to be interoperable across member states, I think without standards, I don't see a solution. Or you should centralize everything in Brussels. But that seems like a very bad idea.
Okay, so hey, I'm just reminding you, it's 5 to 6. Then it's up to you whether I'm glad to stay. But then yeah, it's up to you. We have so many of this. Exactly, yeah.
The word standards seems to mean a lot. Maybe we should choose another word and acknowledge that this is a market. We are providing specifications and targeting certain needs. And we are trying to advertise the use of these specifications for others. And if you're lucky, someone else will pick that specification up and use it. And it will grow over time. We need to provide a solution where this market can exist and you can advertise your specifications. And maybe we not use the word standard or semantic asset or whatever. It's just a specification someone provided. Let's just tell the world about it and hope someone picks it up.
Yes, please, yes.
I wanted to add just a small point of view, public sector point of view. There's a friction about we are talking technological point of view, engineering, architecture point of view. In the public sector, you probably have some laws that tell, or some institution that has the domain ownership and tells you that this thing is named this way. In Italy, we have this problem between vehicles, which the Institute for, how do you call it? One institute is talking about when you break your leg or you have a crash, social security, you have a crash, and they're naming vehicles in their way, and they don't want them to name them in another way, because they say, for us, a car is not the car that someone else says. And this is, for them, it's written in the law, so you have an iteration about, like a legal iteration that you need to take before you get to the optimal solution, if you can. So just
sounds like a little bit of a monopoly locally within a certain part of one country. But it's still wider perspective. It's a market.
The thing that we were saying before, the local, regional, and European is almost the same. Every country maybe has some different nuances that they want to put in the data, and you need to agree on a higher level representation, if you can. But I mean, this is part of the ongoing process.
You know what happened exactly from German government? They tried to make specific standards, let's call it market, to get mandatory European regulation. That's a money printing machine, obviously. If nobody needs it, but you make it regulation and everybody has to do it. Cool, right? So it was declined by European Parliament. I'm really happy. So, but here you see that standards and market is also politics.
Yes.
Okay. So yeah, maybe let's go to. I don't know what to do now, because we can talk about this over beer, but but yeah.
Maybe find the most controversial.
Yeah, let's. There is the next one is from Maria. Ah, very good. Yeah.
Yes, I was thinking about these replicating things to get funded for our research and so on. And I was also thinking that, but at least for me these days, it's like you are not really doing basic research with this project. We are moving towards innovation and industry adoption. And probably that's why in our conference, for example, we have a track for resources, and that is development, and that is engineer. So it's really difficult, this balance between what we do for research, that is nothing that we are seeing here, but we need the funds. Right?
Yes, so this is the statement from Maria. The technological solution or components are mostly there, but ontology reuse is still tedious, and it came out clearly also from the presentation.
Yeah, so that's my question for you, so that you give me ideas for what is next to be developed and done research about.
So
to us for the project.
Say again, what is the question?
Yeah, so what is, if you disagree, what are the needs?
Ah.
Where should we be moving to ask for this new research funding?
Yeah, so there is yeah, very good.
I don't disagree, but I still think there are a few opportunities. And speaking from founders, we also have a lot of technology and solutions already in place, but we are still looking at things towards how can AI help us build models automatically? How can we speed up that process so that like the desk research phase is being fostered, and also like collaboration on the models, because I don't agree that our specifications are like centralized, because I feel like they're very much federated, because a lot of people can give input, but a way to manage the input and feedback and to collaborate on that, and also make sure that these feedbacks get processed and inputted and updated, I think is something we can think about, and would like to see some involvements on that.
Yeah, if I can say something about this. This seems to suggest, and people agree, in some way that technology is not the solution for, of course, ontology reuse. It seems to be a human factor, and this comes also from our experience. So in the end, regardless of the tool support, you have to go there, look into the ontology, understand it. It's something that tools can ease, but not replace the human being that does this job. Really understand what's in there, the semantics that it's only in the head of the expert that really understands what's there. So I think it will never be completely solved by technology. AI can help, but the human factor is so important that the two things will always go in different directions. But that's also the good thing. So we always have a role, and then understanding what we are doing and then getting really into the detail makes then the difference on reusability or not. So it's tedious, yes, but that's how it works in my opinion.
Yeah. Maybe adding to this, so maybe not for every use case, a new ontology is the right way to go. Sometimes you just want to reuse stuff which is already there. So why even define a new ontology? Why just use profiles, use application profiles? Especially when it comes to implementing use cases, you need applications that need some data models, some models to function. So this is why I somehow disagreed, but rather not because ontology reuse is tedious, but because sometimes you don't even need new ontologies, right? But other tools, other techniques might be more promising to solve use cases. Yeah.
I'm again going to make the economics standpoint. The point is that the cost of reusing ontologies is often too high because we're over-engineering them. I remember the big quote from Michael Kay, SOX, the SOX processor, no, the SOX API, XML, nobody? XSLT? XSLT 2 at some point moved from 1 to 2, and they made XPath and XSLT completely type aware. And poor Michael Kay was the guy that needed to do all the coding, right? And I remember he was here in Brussels at some point making a statement, and he says, all this work, and actually, and I never forgot this, I do this, but nobody is interested in the types. They are only interested in the values. And that kept latching in my head. And the point being that for end users, In my case, marine engineers, right, or marine science people, they want to do analysis. They need the values, the typology, the ontology. I'm not saying they're not useful, but they're useful for us kind of people, right? And they should not get in their way. So when we define ontologies, what I find striking, a lot of people are over-engineering, they are adding domains, and yes, when you do an ontology, but when you're just agreeing on the semantics, it should be just the semantics. I have a URI and it means this. Another thing, property paths. People think about, I have the this of the that. Those are a different level of standardization or agreement, right? So agree on semantics, then agree on property paths, and only in the third instance start creating shackle files, ontologies, domain specification, etc., because those are adding costs for those people that are coming from outside. And the level of reuse that is possible on those earlier levels, we should actually enable them and advocate. Who was it? It was you, eh? You were saying a vague level of linking, loose linking has an enormous amount of value, and actually the extra value it has is it would enable people to push out their data, and people like us would finally have a data-driven base where we could check the actual dissonance about, oh, but you're using these models in the wrong way. And actually it would, again, and then we have this marketplace ID, we would actually have a way to measure and calculate the status of the VHS versus Betamax level on, and then I'm going to conclude, because the wise man Wittgenstein said semantics is use, right? So it's in the actual use of the data that we should be deriving the semantics rather than upfront driving and saying this is it because of the ontology. It's the use that actually, yeah, and that's the language model. And then I think we're going also to what Alessandro was saying. It's a human thing. It's not an engineering thing.
Now, I just realized that there's people over there. They're probably watching the game. They deserve to go home. They deserve to go home. So I feel compelled to close the workshop and say a big thank you for the speakers. And it's been really, really good. Next year, we'll probably start with this model, with the statement first, and then we have the presentation if we have time for it. So thanks again. Thanks again from behalf of SEMIC, and we'll see everybody tomorrow at the conference. Thank you.